কিছু নেই। ওকে, নেক্সট যেটা বলবো তোমাদের ফুডিং এর যে ব্যাপারটা আমরা এখান থেকে অ্যারেঞ্জ মানে সাইলেন্টলি বসো। খাওয়া দাওয়ার ব্যাপারটা নিয়ে যেটা তোমাদের মানে যেটা প্রোভাইড করা হচ্ছে ওটা নিয়ে কারোর কিছু সমস্যা বা কোনো কিছু অসুবিধে হচ্ছে কিনা বা কিছু প্রবলেম মনে হচ্ছে কিনা বা ওটাতে কিছু ইমপ্রুভ করার ব্যাপার রয়েছে কিনা, এটা যদি তোমাদের কারোর কিছু থাকে।
খাওয়া নিয়ে কিছু বলবে? কিছু শরীর খারাপ হচ্ছে নাকি খাবার খেয়ে? হ্যাঁ, ঠিক আছে, ভালো লাগছে, টেস্টি, বোরিং খাবার নেই তো, মনোটনি হচ্ছে না তো?
ওকে, আর নেক্সট আরেক, হ্যাঁ ওইখানে একজন কিছু বলবে। আস্তে সবাই একটু সাইলেন্স মেনটেন করো, কিছু বলার থাকলে বলো ডেফিনেটলি।
বলছি খাবারের কোয়ালিটি ভালো, সেটা নিয়ে কোনো প্রসঙ্গ নেই, বাট লাঞ্চের পর থেকে খুব তাড়াতাড়ি খাওয়া হয়ে যাওয়ায় আমাদের খিদে না থাকলেও ডিনারটা তাড়াতাড়ি সেরে ফেলতে হয়, ওই জন্য ডিনারটা একটু দেরি করে করলে ভালো হতো।
তোমাদের তো দেরি করেই দেওয়া হয়েছে কালকে ফার্স্ট দিন। হ্যাঁ,
আচ্ছা আমি
আস্তে 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 একটু আস্তে,
আমি যদিও
তো থাকার বাচ্চাদের বোধহয় 9টার সময় বলেছিলাম, 9টার সময় খাওয়ার বোধহয় খেতে বলেছিলাম।
আস্তে সবাই একটু সাইলেন্স মেনটেন করো। হ্যাঁ
আস্তে আস্তে। আচ্ছা,
তারপরে 9টায় খাওয়া হয়ে যাওয়ায় পরের দিন সকালে 9টায় আবার ব্রেকফাস্ট হচ্ছে, যার কারণে সেটাই তো পেট ভরছে না, ওই জন্য মাঝখানে তো খিদে পেয়ে যাচ্ছে।
দেখছি কি করা যাচ্ছে।
আচ্ছা ঠিক আছে, তোমরা ব্যাপারটা যেটা বলেছো অবশ্যই ম্যাডাম শুনলেন।
অ্যাকচুয়ালি কিছু আবার ওই চায়ের সাথে কিছু ব্যবস্থা করতে হবে বিস্কিটের বদলে, তাই তো? চাটা তো ঠিক আছে, সকালে তো উঠে না, ব্রেকফাস্ট তো তোমাদের 8:30তেই দিয়ে দেওয়া হয়, ব্রেকফাস্ট তো 8:30 থেকেই রেডি করা থাকে, তোমরা হয়তো নামতে দেরি করো, লাঞ্চ আর ব্রেকফাস্টের মাঝখানে গ্যাপটা একটু বেশি।
না অ্যাকচুয়ালি ব্যাপার যেটা হয় আমার যতদূর মনে হয় ম্যাডাম, আমার যতদূর মনে হয় এখানে যারা বাবা ডিনারের দায়িত্বে রয়েছে তারা তো মানে তারা সার্ভিসটা প্রোভাইড করে বাড়ি চলে যাবে, তো মানে নর্মালি ধরো সেই জায়গাটাতে মানে তোমাদের এতজন ছেলে মেয়ের খাওয়া দাওয়ার ব্যাপারটা কমপ্লিট হলে ওনারা বেরোতে পারবেন। এবার ধরো শীতের দিনে আমরা সবাই লেট নাইটে বিছানায় যাই, এটা ফ্যাক্ট, কিন্তু ধরো এই জায়গাতে যারা রয়েছে তারা তো সবাই ধরো তোমাদের খাওয়া দাওয়ার ব্যাপারটা শেষ না হলে বাড়ি ফিরতে পারবেন না, তো সেই জন্যই হয়তো একটু আর্লি হয়ে যায় আর কি। তো ম্যাডাম তবুও ব্যাপারটা দেখছেন, তোমরা যখন বলেছো ম্যাডাম তবুও দেখছেন, বা যাতে করে পরের দিনের ব্রেকফাস্টটা আর্লি করা যায় সেটা ম্যাডাম দেখছেন।
আর্লি ব্রেকফাস্টটা 8:30তেই আমি বলে দিচ্ছি, 8:30 থেকে কিন্তু রেডি থাকে, তোমরা যদি রেডি হয়ে চলে আসো 8:30টায় নিতে পারবে, যারা এবার টাউন থেকে আসছে তাদের 9টা বাজছে, কিন্তু তোমরা 8:30টায় নিয়ে নেবে, সেটা বুঝতে পেরেছি, কিন্তু সেটাই মুশকিল, মানে মেন্টার সায়েন্টিস্ট সেশন চলতে থাকে তো তখন ওই মানে অফ করে যাওয়া যায় না আর কি, ওইটা একটু কনসিডার করতে হবে। কি বলবে ল্যাব নিয়ে?
আচ্ছা আমি আরেকটা যেটা তোমাদেরকে জিজ্ঞেস করব, আমি বোধহয় ও উঠছে ওইটা নিয়ে বলার জন্য, তো আমি ওই তোমাদের যে ল্যাব ডেমনস্ট্রেশন হচ্ছে এই ল্যাব ডেমনস্ট্রেশন নিয়ে একটা ফিডব্যাক যদি তোমরা দাও যে এই ল্যাব ডেমনস্ট্রেশন কেমন হচ্ছে।
ল্যাবের টাইমটা একটু বেশি স্পেন্ড করতে চাইছি, আমাদের সেমিনার টাইমটা মানে অনেকক্ষণ হয়ে যাওয়ার জন্য আমরা প্র্যাকটিক্যালি ল্যাবগুলো সমস্তগুলো মানে করতে পারছি না, তো ওখানে টাইমগুলো অনেকটাই কম হয়ে যাচ্ছে, তো আমরা ওখানে ল্যাব টাইমটা একটু বাড়াতে চাইছি, মানে আমাদের যদি ল্যাবে একটু বেশি টাইম দেওয়া হয়।
অ্যাকচুয়ালি ব্যাপার যেটা হচ্ছে বাবা, আমি যতদূর জানি মানে তোমাদের এই যে শিডিউলটা এটা কিন্তু ওই ডিএসটি থেকেই করে দেওয়া, মানে ওনারাই এই শিডিউলটা করে দিয়েছেন।
হ্যাঁ, তো 2টো থেকে 3:30 যে ল্যাবটা ছিল ওইটা তো পুরো অফ হয়ে যাচ্ছে।
হ্যাঁ, এবার আরেকটা যেটা ব্যাপার থাকছে বাবা, আমার যতদূর মানে আমরা যেটা সবাই দেখতে পাচ্ছি যারা আসছেন তারা অ্যাকচুয়ালি হয় মানে স্টেটের একদম মানে কলকাতার দিক থেকে বা তোমার স্টেটের বাইরে থেকে আসছেন, তো কোনো ক্ষেত্রে ওনাদের আসতে একটু দেরি হয়ে যায়, তো যে কারণে আমাদের প্রোগ্রামটা শুরু হতে দেরি হয়ে যায়। এবার যারা ধরো রিসোর্স পারসন বলতে এখানে উঠছেন ওনাদেরকে তো মাঝপথে থামিয়েও দেওয়া যায় না যে আপনার 1 ঘন্টা টাইম ছিল আপনি কেন 1.5 ঘন্টা নিচ্ছেন, মানে ওনারা যে লেভেলের মানুষজন ওনাদেরকে সেই জন্য ধরো আমরা মাঝপথে আটকাতেও পারি না, মানে এই জায়গাটাতে একটু টাইম ম্যানেজ করা আমাদের পক্ষে হয়তো অসুবিধে হয়ে যায়। তবে আর্লি করার যে চিন্তা ভাবনাটাই শীতের দিনে সকালে না আর্লি করাটাও পসিবল নয়।
ব্যাপারটা হচ্ছে এটা লাঞ্চ টাইমের যে ব্রেকটা, ওই ব্রেকটা যদি একটু বাড়ানো যায়, কারণ আমরা সঙ্গে সঙ্গে সেমিনার থেকে যে মানে যাই হোক করে লাঞ্চটা খেয়ে আমাদের সাথে সাথে উপরে চলে যেতে, ওটা খুব অসুবিধে হচ্ছে,
বুঝতে পেরেছি,
4-5 তলা করে উঠতে হচ্ছে, এটা আমাদের খুবই অসুবিধা হয়।
অ্যাকচুয়ালি লাস্ট 2 ডেজের শিডিউলটা যেটা আমি ম্যাডামদের দেখেছিলাম মানে আমাদের প্রোগ্রামের, তো ওটা একটু প্যাকড শিডিউল ছিল, তবে আজ থেকে বোধহয় একটু তোমাদের রিল্যাক্সেশন থাকবে, মানে
আজ
যেটুকু
থেকে একটু
একটু রিল্যাক্সেশন থাকবে আজ থেকে, হয়তো ওই চাপটা তোমাদের হবে না, যেরকম ভাবে তোমাদের ধরো খাওয়া দাওয়া করেই দৌড়তে হচ্ছিল প্র্যাকটিক্যাল গুলো করার জন্য, ওটা হয়তো আজ থেকে একটু হলেও কম হবে। আসতে বাবা, একটু সবাই সাইলেন্স মেইনটেইন করো।
একটা শিডিউল যেই টাইমে শুরু শেষ হচ্ছে তারপরে শিডিউলটা ঠিক সেই টাইম থেকে কেন শুরু হচ্ছে? যেতে তো কিছুটা হলেও টাইম লাগবে আমাদের। শুরু হচ্ছে না কিন্তু সেটার টাইমটা তো কম হয়ে যাচ্ছে। একটা বিল্ডিং থেকে আরেকটা বিল্ডিং এ যেতে তো টাইম লাগছে না।
তাদেরকে তো আমরা বারণ করতে পারবো না, না সেই জন্য একটু প্রবলেম।
আর কারো কিছু কোয়ারিজ? হ্যাঁ বাবা।
স্নানের খুব অসুবিধা হচ্ছে। একজন একটা বাথরুমে ঢুকে গেলে সেটা পুরোটাই লক হয়ে যাচ্ছে, আর কেউ কোনোভাবে সেটা ইউজ করতে পারছে না।
ও,
কোথাও বালতি নেই তো।
আচ্ছা ঠিক আছে, এই ব্যাপারটা ম্যাডাম শুনলেন, এটা অবশ্যই ম্যাডাম দেখছেন। হ্যাঁ,
একটা প্রোগ্রাম তো সবাইকে একটু টাইমে ম্যানেজ করতে হবে, ঠিক আছে?
আর কিছু বাবা, আর কোনো সমস্যা?
পারবো না বলো।
পেছনের দিকে আছে ম্যাডাম।
না না, তোমাদের দোতলায়ও বলেছিলাম ওয়াশরুমগুলো ভালো ঠিকই আছে। আচ্ছা, আমি আজকে রুমে গিয়ে বলে দেবো উপরে যে টয়লেটগুলো আছে সেগুলোতে টয়লেট ইউজ করতে, আর ওয়াশরুমগুলো স্নানের জন্য ইউজ করতে, তাহলে তো সুবিধা হবে। ওপরে তো আছে, তো ওপরে তো দোতলা তিনতলা সবাইতেই তো ওয়াশরুম আছে, চাইলেই তোমরা বললেই আমরা কালকে ব্যবস্থা করে দিতাম, কোনো অসুবিধা নেই।
Welcome to day 3 of our exciting science camp. I hope you all had a restful evening, are ready for another day full of knowledge, inspiration, and hands-on learning. Over the past 2 days, we have explored some truly fascinating topics, and today we are continuing the journey with even more thought-provoking sessions and interactive experiences. As we know, we had the privilege of hearing from brilliant scientists and experts from various fields. And today promises to be just as exciting, with a fresh set of groundbreaking topics and innovations to explore. So without further ado, let's dive into the first session of the day.
Now we would like to welcome on stage Professor Brojagopal Bag, Professor, Department of Chemistry and Chemical Technology, Vidyasagar University, Midnapore. We would like to request our madam to felicitate him. Thank you, sir. Professor Brojagopal Bag did his Masters of Science in Chemistry from the Indian Institute of Technology, Kharagpur in 1989 and got his PhD from the premier research institution, the Indian Institute of Science, Bangalore in 1994. Then he moved to Germany with the prestigious Alexander von Humboldt Fellowship and spent 4 years in Rhodes University, Bochum, Germany. Then he came back to India and joined the Vidyasagar University as a reader in the year 2000, and where he became a full professor in the year 2008. Along with teaching, he has devoted his life for research in diversified research areas such as plant metabolites, as renewable nanochemistry, advanced functional materials, targeted drug delivery, etc., in addition to the main field of organic chemistry. He has already produced 20 PhD scholars and published research papers in many leading journals, several patents, and delivered invited lecture in Indian and abroad, including invited lecture in IUPAC symposia. Based upon his academic achievement, the Ministry of Human Resource and Development recognized him for the Leadership for Academicians Program LEAP India in the year 2019, jointly organized by IISER Kolkata and Harvard University, USA. He is the founder president of CRS and he is also the editor-in-chief of the Society Journal. Currently, he is serving as the coordinator of Incubation Center and also as a director, CDOE, Vidyasagar University, Midnapore. He is the recipient of many national and international awards. In 2024, he has been recognized by the Royal Society of Chemistry, London, UK, as the Fellow of Royal Society of Chemistry. Now, sir, over to you, please.
Good morning, everybody. I thank the organizers of this Inspire program for their kind invitation. And I'm really very pleased to be here. And thank you, madam, for your very nice introduction. I'm really overwhelmed by seeing such a great audience who are going to be the future frontiers, future leaders of our country in science and technology. And for that only this program is all about. And well, as madam told that I got the opportunity to carry out my research in the premier institution like IISc Bangalore, and then Germany as a Humboldt fellow, and then came back to India and joined Vidyasagar University in the year 2000. And currently, in fact, in addition to teaching and research, I am holding various administrative positions. So as you can see, like I'm the director, so I am really very busy. But still then, whenever these people come, I love coming to this place because these people, give such a nice hospitality and such a nice campus. So I love this. I am sure you are loving this too. So, let us give them a big hand because they are taking so much of trouble to, organize such a program. It's really fantastic. Thank you very much. Now, can you see beautiful colors here? You like it, right? And these are fruits. Fruits from the plant Bixin or Ilana. I am sure there are some people from plant taxonomy, they will know. Bixin or Ilana mane বাংলায় যার নাম হচ্ছে সিন্দুরি গাছ। কি শুনলে? সিন্দুরি। সিন্দুরি মানে কি সিন্দুর তাহলে, তাই না? সিন্দুর মনে হচ্ছে না তাই? সিন্দুর। আর ইনফ্যাক্ট যদি এই গাছটার মানে এটা হচ্ছে ফল, ফলের রংটা এরকম, তার ভেতরে যখন ফলটা ফলটা যখন পেকে যায় তার মধ্যে যে সিড সেটাও দেখতে লাল। And as you can see, there are some seeds, perhaps, you can pass it around and you can take 2 seeds each. I hope there are enough seeds, more than 400, so you can take 2 seeds each, so you can pass it on and you can feel for yourself that these are the seeds. Okay, so madam, perhaps you can pass it on. Bixin or Ilana. And এখান থেকে সত্যিকারই ভেষজ সিন্দুর তৈরি হয় এবং এটা আমাদের বাগানে জন্মায় এবং এই যে ফটোটা না, এই ফটোটা আমাদের বিদ্যাসাগর ইউনিভার্সিটির বাগান থেকে নেওয়া হয়েছে। তাহলে আমাদের মাটিতে জন্মায়, আর ভেষজ শুধু সিন্দুরই নয়, এখান থেকে যে রঙটা পাওয়া যায় সেই রঙটা না নন টক্সিক, খাদ্যেও দেওয়া যায়, তাই মিষ্টিতেও দেওয়া যায়, মিষ্টি। আবার জামা কাপড়ও রং করা যায়। এবারে ইন জেনারেল যে কোনো রঙিন পদার্থ আমরা ভাবি বাবা সাম টক্সিক কেমিক্যালস আর দেয়ার, বাট দিস ইজ ওয়ান অফ দোজ রেয়ার ফাইটোকেমিক্যালস যেটা কিন্তু খাবারেও ব্যবহার করা যায়। এটা কয়েক বছর আগে পেপারে বেরিয়েছিল, নিউজ পেপারে। I didn't know the plant. Then it took some time for me to identify the plant. And once I do the plant, then I had some urge যে এই গাছটার ফলটাকে আমাকে পেতেই হবে। তারপরে it took 5 years for us to do some research, and I am really very happy to share with you. যদি এখানকার কয়েকটা লাইট বন্ধ করা যায়, এখানকার কিছু লাইট বন্ধ করা যায়। হ্যাঁ, ওই দিকের লাইটটা, ওই দিকের লাইটটা। Oh, okay, camera, okay, but you can see it better, I think. Okay, all right. Oh, okay, all right. But anyway, that you can make out better. So this is how the color is, and as you can see, now starting from simple curiosity, জানার ইচ্ছা থেকে, আবার যেহেতু আমার রিসার্চ ল্যাব আছে, ওদেরকে মোটিভেট করলাম, ইন্সপায়ার করলাম। জাস্ট গত সপ্তাহে ইউ ক্যান সি দ্য ফার্স্ট ভেসিকুলার সেলফ অ্যাসেম্বলি of an apocarotenoid Bixin in aqueous liquids and its antibacterial activity. And this is one of the leading journal in chemistry and Asian journal. And here you can see, here it's me and 2 of my research scholars. And that's what I was discussing with one of the scientists here a couple of minutes ago, and perhaps we can have some collaborative work also to take this chemistry forward. So এই যে বলছি যে হ্যাঁ, কিউরিওসিটি ড্রাইভেন রিসার্চ, জানার ইচ্ছে একেবারে সাধারণ জিনিস, আমি গাছটাকে চিনতামই না, কিন্তু আজকে দেখো কোথায় নিয়ে গেছি। আবার এই গাছটা আমাদের মাটিতে ফলে, তাহলে এই জিনিসটা আমার মাথায় এগুলো কোত্থেকে? হাউ ডিড আই বিল্ড আপ দিস? তার কারণ কি, আই হ্যাভ ডান মাই মাস্টার্স ফ্রম IIT খড়গপুর অ্যান্ড দেন PhD ফ্রম IIT ব্যাঙ্গালোর। তাহলে আবার মাটিতে ফিরে এলাম কি করে? Well, as you can see, we are here now. Here is our country and we are here now, and this is our university. This is Vivekananda Sabhagriha, and if we enlarge we will see that yes, এই যে জায়গাটা, হ্যাঁ, আমাদের মুখ্যমন্ত্রী বলেন যে হ্যাঁ জঙ্গল মহল, দেখছো না, ফুল অফ গ্রিন সেখানে। তাহলে আমাদের এখানে এই যে বিদ্যাসাগর ইউনিভার্সিটি, মিদনাপুর সিটি কলেজ, আরও ডিপ ইনসাইড ফরেস্ট এটসেট্রা। সো উই ডু হ্যাভ হিউজ ফরেস্ট, ওকে। অ্যান্ড ইউ ক্যান সি দিস, that this gentleman is climbing up on the tree, and you can see এই যে খেজুর রস, তারপর সেখান থেকে নলেন গুড়ের সন্দেশ, কারই না ভালো লাগে এই সময়, তাই না? রসগোল্লা, এটা কিন্তু এইখান থেকে তৈরি হয়। And as you can see here, every year we are seeing a cart, and this gentleman is collecting the juice from here. তার মানে কি, this is renewable, and that is how you can see that the plants can grow in every season. So this is also renewable. Just like we have termed the solar energy as the renewable energy. Because why? Every morning we get fresh sunshine. Tahole, can we term the phytochemicals that we get from the plants as also renewable chemicals? Can we term? Because if we think of the constituents of any plants, we'll find many chemicals, different kinds of chemicals. Tahole, if we can term the solar energy as renewable energy, can we term the phytochemicals that we get from plants as renewable chemicals? Yes or no? Yes. তাহলে দেখো, এই যে see the golden rice that we grow in every season, that is also renewable. So as you can see here, plant metabolites are the most significant source of renewable chemical feedstocks for sustainable future. This is taken from one of the journals. And as you can see, the energy comes from, so if we go back to the school book, so sunshine and the energy is being conserved by the plants, and then in the plants you have, thousands of chemical transformations, and the energy is being conserved, and that energy we get, and in addition we get n number of phytochemicals. And then if you remember this food pyramid, that starting from the lower like plants, this is how it goes on, and how the energy is reducing here in 10%, but everywhere you will see that the energy is coming from the sun, and then only we go up and we are somewhere here. Tahale we have to depend upon plants, and then the energy is coming from sun via plants. And then if we think of the current dependence of society, it has been shown that more than 98% of all organic chemicals are from petroleum resources. If we think of the modern civilization, have a look. Crude petrol, that is being fractionated. So we can see lower the alkanes, we get the cooking gas, and then petrol, diesel, so all kinds of vehicles including aeroplanes, etc. And the remaining, that is being used for the construction of roads, correct? Tamane, the modern society is dependent fully, almost fully, on petroleum resources. But are those renewable? Petroleum resources, are those renewable? But plants, renewable. Do you agree with them that the petroleum resources are not renewable, but plants are renewable? Someone will say, well, tahole petrol kotheke elo? As you can see here, underneath the 300 to 400 million years ago, the tiny animals, and then the other plant metabolites, those were buried underneath, and then there is slow transformation under very high pressure and also temperature, correct? And then we got these petrol, kerosene, coal, etc., etc. But then someone will say, okay, এখন তাহলে গাছগুলোকে মাটির নিচে ভর্তি করে দেবো, and then after 1 million years I'll come back and see what happens. Is it possible? তাহলে that is not possible, right? তাহলে to have a sustainable society, definitely we have to directly depend upon plants. Okay? And you can see now, তাহলে কখন থেকে আমরা এত বেশি ডিপেন্ডেন্ট হয়ে গেলাম on plants? এই যে আমাদের মডার্ন সিভিলাইজেশন, আজকেও আমি কারে করে এসেছি, ম্যাডামের সঙ্গে এসেছি, খুব ফার্স্ট ক্লাস কার, অ্যান্ড দ্যাট ওয়াজ ড্রাইভেন বাই পেট্রোল কার, কারেক্ট? কখন তাহলে এটা শুরু হলো? দেখো, এটা কি হাজারো বছর ধরে চলছে? কি মনে হয় কতদিন? দ্য হিউম্যান সিভিলাইজেশন কতদিন হলো ডিপেন্ডেন্ট অন পেট্রোলস? কি মনে হয়? 500, 1000, 1500, 2000, 1 লাখ বছর ধরে ডিপেন্ডেন্ট অন পেট্রোল? কতদিন? 100 বছর? 100 বছর, ও বলছে 100 বছর, তোমাদের কি মনে হয়? 100ই হবে অনলি, তার মানে 100 বছর, মাত্র 100 বছর ধরে এটা হচ্ছে, তাই তো? ওয়েল, কত বছর ডিপেন্ডেন্ট অন পেট্রোল, অ্যান্ড দেন দিস কার, ভেরি নাইস ড্রাইভিং কার, হ্যাঁ? কত বছর? Well, you can see here, you can search in the internet, all of you are having internet facilities. 1885 সাল, here you can see the Carl Benz, first automobile, the Benz patent motorwagen. They got a patent 1885 সালে। ফলে আমাদের যে বর্তমান এভাবে, তারপর দেখো কিভাবে হ্যাঁ, বিভিন্ন ধরনের কার, তারপরে এরোপ্লেন, এটসেট্রা এটসেট্রা। অ্যান্ড ইউ ক্যান সি হিয়ার 1908 first oil discovered in an Arab nation. So you can search in the internet. I have taken the snapshot from the internet only. তার মানে এই যে ডিপেন্ডেন্স, এটা কিন্তু খুব বেশি পুরনো নয়। And here you can see that oil is not a renewable resource. Oil can only be used once before it is used up, and it cannot be naturally created or replaced. It takes thousands of years and even millions for the oil to be produced. Similarly, if you go to a gold mine, many of you are wearing gold ornaments, correct? If you go to a gold mine, আজকে কিছু গোল্ড তুললে পরের দিন ঝুড়ি নিয়ে আবার গেলে আবার কিছু গোল্ড, আবার গেলে চলতেই থাকবে, তাই তো? তাহলে সেখানে সে গোল্ড তৈরি হচ্ছে না, তাহলে দ্যাট ইজ নট রিনিউয়েবল, কারেক্ট? তাহলে দ্যাট ইজ নট রিনিউয়েবল। বাট থিঙ্ক অফ দিস গোল্ডেন রাইস, we can grow in every season. So here only the significance, and as you can see here the quote, that more than 98% of all organic chemicals are derived from petroleum. This is taken from one of the leading journal chemistry accounts of chemical research. Okay. And it states that achieving a sustainable chemical industry dictates switching from depleting finite sources to renewable feedstocks. তাহলে এই যে sustainable, what does it mean? Well, sustainable means, suppose we are using something today, then tomorrow, and then day after, and then generation after generation, but we should not compromise with the need of the future. We should continue, then it will sustain. That is why the term sustainable. তাহলে in that sense, the petroleum resources, are those sustainable? Will it grow? Well, definitely we have to switch. So it states that achieving a sustainable chemical industry dictates switching from depleting finite sources to renewable feedstocks. And here you can see the profile. See, এই যে green, এই যে গ্রিনটা হচ্ছে তোমার রিনিউয়েবল, তারপরে এলো কোল, ব্ল্যাক। এখন কিন্তু কয়লার ওই আঁচ ফাঁচ খুব একটা দেখতে পাওয়া যায় না, কিন্তু আমি যখন মেদিনীপুর কলেজে আমার গ্র্যাজুয়েশন করেছি তখন দেখেছি সকালবেলা যখন বেরোতাম না মর্নিং ওয়াক করতে বা হয়তো টিউশন পড়তে যেতাম, তখন দেখেছি যে হ্যাঁ সেই চায়ের দোকানে আঁচ ধরাচ্ছে, গোটা শহর পুরো ধোঁয়ায় ভর্তি। হ্যাঁ, এখন আর দেখি না খুব একটা, হার্ডলি এনি। হ্যাঁ, তার মানে কি কয়লা এখন শেষ হয়ে গেছে? হার্ডলি এনি, দু একটা মানে কয়লা, দু একটা জায়গায় কয়লা কিনতে পাওয়া যায়, কয়লার পাওয়াই যায় না। আর হচ্ছে তার আগে কি ছিল না, উই হ্যাড দিস গ্রিন অ্যান্ড রিনিউয়েবল সোর্স, অ্যান্ড দেন অ্যাজ ইউ ক্যান সি, তার মানে কয়লা ড্রপ করে গেছে, দেখছো এই 2000 সালের এইখানটাতে ড্রপ করে গেছে। আবার হোয়াট হ্যাজ টেকেন আপ, দ্যাট ইজ this natural gas and oil এইখানে। So we are here now, but you can see now that it has started falling, because it has to fall because we don't have much, and as you can see this green is again picking up, and that's where like these plants can play a role. And what is the meaning of this Rasayan? Rasayan is this Sanskrit word. Rasa means juice, and ayana means method or paddhati. It has been practiced in India since the Vedic ages, 5000 BC or even before, as many Rasayana therapies have been described in Atharva Veda. What is this? The group of herbal remedies or formulations when used to provide cure or defense against disease and promote health and longevity were called Rasayana. This Rasayana Shastra has been considered as a natural science, means Prakritik Vigyan, and when I was in Germany, they call it to be Naturwissenschaft. মানে ইংরেজি এবং জার্মানটা একটু কাছাকাছি, ফলে ন্যাচারাল সায়েন্স, হোয়াট দে সে ইন জার্মান ল্যাঙ্গুয়েজ, Naturwissenschaft means again natural science, and we call in like Hindi or Bengali this Prakritik Vigyan in India, as we know now the chemistry subject in English. All right, and here you can see a recent paper which appeared again in a leading journal Chemistry, that reimagining priorities. What should be the priority in chemistry? And chemistry is central science. What it says, a central science, freedom from fear and want. And as you can see how chemistry correlates to various aspects of society and other subjects of interest. All right? And here, like at Vidyasagar University, we start with plants, so I have shown you. So have you got those seeds now? সিটগুলো খুলেছে না খুলোয়নি? তোমাদের কাছে পৌঁছেছে সিটগুলো? কোথায় রেখেছো? ওটা না ওই এক ফোঁটা জলে রেখে দেবে, নরম হয়ে যাবে। তারপর না এরকম করে দেখবে যে হ্যাঁ রঙটা কিন্তু হাতে হাতে একটু করে বেরিয়ে আসছে, আর ওখান থেকে সত্যিকারের সুন্দরের মতো রঙ বেরিয়ে আসে। ফলে আমরা এই যে প্ল্যান্ট থেকে we isolate compounds, purify, so those become renewable chemicals, and then we derivatize whenever needed, study their self-assembly, and then advanced studies. Okay, so everywhere we start with plants, and we have published several papers in leading scientific journals where like these people, they have carried out their PhD, and then now they have moved to some other places, and they are now established scientists or in academics or in industry. So these are the areas in which we are carrying out our research now, like self-assembling systems, plant metabolites as renewables, nano architectures. Again, this correlates with the nano also. So nano architectures from renewable nano-sized triterpenoids, chemical constituents of Chyawanprash, okay, and the osteobargo plants, and then hybrid material, catalysis, and so on and so forth. And today, like I'll just cover briefly some of these. As you can see, those have been featured even in the cover page of the leading journals. So here you can see the Arjuna plant, and there are some other plants, as you can see, which grow in our soil. So like see, we can get molecules. So this is a class of molecules which contains 30 carbons, and that is why we term these as triterpenes. So those are obtainable from various plants surrounding us, and then সেখান থেকে আবার রিভার্স করে we can get various morphologies like vesicles, fibers, flowers, and so on, and then the chemistry beyond. And also, how does it correlate to the nanoscience? Nano means, what is the meaning of nano? Nano means size-wise very small, right? চুলের মতো এতটা তার ডায়ামিটার না, তার থেকেও কম, অনেক অনেক কম। কতটা কম? ন্যানো means 10 to the power -9, absolutely -9, 10 to the -9 meter. And angstrom, you know angstrom? -10. তাহলে অ্যাংস্ট্রম বড় না ন্যানো বড়? তাহলে 1 ন্যানোমিটার সমান কত অ্যাংস্ট্রম? অ্যাবসলিউটলি কারেক্ট, অ্যাবসলিউটলি কারেক্ট। আবার যদি আমরা, তোমরা এত ভালো ছাত্র, এত সুন্দর বলছো, আই এম রিয়েলি এনজয়িং দিস। as you can see now, see the dimensions of various atoms here for organic compounds. Carbon 0.15, nitrogen 0.15, here also almost 1.5, right? So 0.154, 0.150, 0.146, hydrogen 0.07. And if we think of the metals which are mostly explored in nanochemistry, this palladium, silver, gold, cesium, this is the bigger one. As you can see here, none of these have nano dimensions. So that means if you have to give 1 nanometer, তাহলে you need 3.5 atoms of gold side by side, or 3.3 atoms of silver side by side, or 3.8 atoms of palladium side by side. তাহলে if you have to get a nanoparticle, তাহলে you need many such atoms in 3 dimensions, thousands of atoms, so that it will form a crystal which will have 20-30 nanometer diameter. Think of organic compounds, সেক্ষেত্রে এই যে ইন্ডিভিজুয়াল অ্যাটমগুলো সেগুলো খুবই খুবই ছোট, but how nature has created them. And as you can see here, there is an emphasis on this nanoscience research based upon the lecture delivered by Richard Feynman. He's a very, very famous physicist. And what he proposed accommodated. So it's not data nano, but nano. We are talking about nano, and that's what like this Richard Feynman, he delivered a lecture. So this is taken from his lecture which was published in a journal. And you can see now, how the nanoparticles are synthesized. There are various approaches. That means you can start from atoms. You can now assemble them, it forms a cluster, and you get nanoparticles. I mean, see, single atom is sub-nano, angstrom level, then several atoms together, it becomes nano. And it can be either from the bottom to up, angstrom to nano, or from macro, then you disintegrate, it goes to nano level. So that is called top down, or bottom up. There are two approaches. Okay, so these are the ways, the nanoparticles are synthesized in the laboratory. And you can see this C60, Buckminster fluorine, and then carbon nanotubes. So these are nanotubes. But think of organic compounds, the terpenoids, which contain multiple of these isoprene units, C5 isoprene. But the gentleman, if we think of the status of science about a century ago, we did not have this much of facilities because NMR was not there, IR was not there, UV was not there. But still then, people are trying to do some chemistry just by disintegration, combustion, or simple transformation. Thank you. আপনার অফিসেই ছিলাম তো ঠিক আছে We'll discuss. Oh, please. Thank you for coming. এবারে that is how, like, either this is bottom up approach or top down approach to get particles of nano dimensions. But look at the compounds which are obtained. Then you can see retinal. Yes, lots of compounds starting from C5, which is again sub-nano, but think of the nature has created them as nano molecules, and that is how now in plants, in different parts of the molecule, it will put some functional groups. So they will have different compounds, but the dimension remains almost same. And the way nature has created that these are all nanos. Correct? This was not looked at before, but when I joined with the university, I became curious, and then I paid attention. So as you can see here, এই যে ডাইমেনশন দেওয়া আছে, দেখো তো 1 থেকে 4 ন্যানোমিটারের মধ্যে সমস্তই পড়েছে। এবারে মলিকুলের চারদিকে যদি মনে করো হাইড্রক্সি, কার্বক্সি, অ্যালডিহাইড, অ্যামিন এটসেট্রা ফাংশনাল গ্রুপ থাকে, তাহলে ন্যানো অ্যান্ড দেন ফাংশনাল গ্রুপ, তাহলে কি বলবো? ফাংশনাল ন্যানো। হলো, nature has created them. Can we investigate? Can we isolate and then find out their properties? So that is how, like, see, slowly you will learn that if you have such functional groups, they can now join hands. We have our body, but we can shake hands with others. অথবা সাইড বাই সাইড এরকম করে অনেক কিছু আকৃতি ফর্ম করতে পারি, মলিকুলও তাই করতে পারি। দেখো এই যে ফাংশনাল গ্রুপ না, এবারে হাত ধরলাম ছাড়তেও তো পারি। দিস ইজ ফেনোমেনন, ইউ ক্যান হোল্ড ভেরি স্ট্রং লাইটলি। ওকে, ঠিক আছে, কেমন ধরবে, যা যেরকম ক্যাপাসিটি এরকম ধরবে, অ্যান্ড ইট ইজ স্পন্টানিয়াস। সো ইট ক্যান নাও অ্যাসেম্বল অ্যান্ড ফর্ম higher order structures. And that is how, in fact, if we think of our body, we do have thousands of molecules inside our body. Molecule তৈরি হয়ে গেল, কিন্তু যে দেহ তৈরি করতে গেলে you have this kind of interactions everywhere in physiology. One is covalent bond to form molecules, but once you get the molecules, then that is chemistry beyond molecule, that is supramolecular chemistry. কি বললাম? By these non-covalent interactions, just the way we join hands, correct? So it can form various order structures. And again, I'm telling you, as I showed you, that chemistry is central science, and very often, see, this is curiosity driven. That means we keep on carrying out experiments and follow the course of transformations by observation and analysis. And science is not compartmentalized. Very often it crosses its boundary. So during its journey, it crosses its boundary and lands in other branches of science. And sometimes this curiosity, as I told you, as I showed you, that molecule or that fruits of Bixin, তোমরা পেয়ে গেছো? ও পৌঁছয়নি, তার আগে শেষ হয়ে গেছে। কোথায় গেল সেই পুটলি? পুটলি এখন কোথায় ঘুরছে? এই ও অলমোস্ট শেষ হয়ে গেছে, অলমোস্ট শেষ। ঠিক আছে, well, maybe I can send, I got some samples, so I just distributed, so you know, কি হয়তো 2-3টে করে নিয়ে দিয়েছি, যাই হোক, it was there. But as I told you, very often the various branches of science, they crosses its boundary, and even an entrepreneur, scientist, do you know the example? Even a businessman, an entrepreneur, he can also become scientist. How? Do you know the name? An entrepreneur became a scientist, and he taught the scientists. How? Have a look. Antonie van Leeuwenhoek. Now you know, correct? So the history of microscope. He was born on October 24, 1632 in Netherlands, and then at the age of 16 he became a bookkeeper's apprentice at a textile shop. জামা কাপড়ের দোকানে কাজ করছে। এবারে জামা কাপড়ের দোকানে কি সেই ক্লথটা কেমন দেখতে গেলে তোমার একটা ম্যাগনিফাইং গ্লাস দরকার। So he bought some magnifying glass. But then he was so curious to look into the texture of that textile. He learned how to get those magnifying glass. And then by doing that, what he did, he in fact constructed one microscope of this sort. This is the one that he made. So he did not have any formal training in science, but his curiosity to look, to nature in greater detail made him a scientist. And then what he did, তার মানে কি সে নিজেই ম্যাগনিফাইং গ্লাস তৈরি করলো, তারপর একটা মাইক্রোস্কোপ বানিয়ে ফেললো, and then looked into a drop of water with his high-end microscope having about 200 times magnification. And what he found, that he জলের মধ্যে কিছু creatures which are moving, that people did not believe him. Then he was invited by Royal Society of Chemistry to demonstrate that yes, there is something which can be seen under a microscope. And then he was successful. And then people believed him, and then he became the father of microbiology. A completely new area was invented. And then as you can see the length scale now, human eyes we can see up to this, and then magnifying glass up to this 1 millimeter, and then conventional light microscope up to 100 or 200, and then even to go beyond that, one has to use this electron microscope or X-ray crystallography, and you can think of the dimensions of various living objects like or living systems like human, and then heart, and then chicken, etc. That is how, and then DNA nanometer length scale. And then the question is, how does it help in our fundamental understanding? Well, as you can see here, with this particular example, which is just published, we can start with this. This you have seen before, and then if you dry it, পাকা ফল, আর এই যে সিডটা তোমাদের সঙ্গে শেয়ার করেছি এখন, এইগুলোই তো, তাই না? এইগুলো হলো। এবারে যদি এটাকে নিয়ে ল্যাবরেটরিতে এক্সট্রাকশন করা হয়, যেটা তোমাদের বললাম, ইয়েস ইউ ক্যান সি, মনে হচ্ছে সুন্দরের মতো। এই জনের নামই হচ্ছে সিন্দুরি হলো। এই যে দেখছো ফিল্টার করছি, পুরো এবারে ডিপ রেড কালার, লার্জ কোয়ান্টিটি ওইখান থেকেই পেয়েছি হলো। অ্যান্ড দেন this is the compound that he got, and then see the dimension 2.44 nanometer nature has created. কি দেখলে? সেই ন্যানো সাইজ মলিকুল পেয়ে গেলাম, ভগবানের দান পেয়ে গেছি। You can see it's called amphiphile because you have a carboxyl group মনে করো, that is polar, and then এই যে ব্যাকবোনটা নন পোলার, অ্যান্ড দেন এই দিকটা আরেকটু হালকা পোলার, COMe। তার মানে এখানে পোলার এবং নন পোলার। এবারে আমরা কি, বিং এ কেমিস্ট, উই লুক ইনটু দ্য স্ট্রাকচার অফ দ্য মলিকুল অ্যান্ড দেন থিঙ্ক অফ ওকে হাউ, what kind of chemistry we can get from there. If you have extended conjugation, you will learn very soon it can be colored. Cano color, because of extended conjugate, you have double bonds, the conjugate, very soon you will learn যে হ্যাঁ you can get color হয়ে গেল। আবার দেখলাম যে হ্যাঁ you have non-polar backbone হলো, and then polar part, non-polar part, তার মানে কি দুটো পার্টই আছে, ব্যাং জলে এবং ডাঙ্গায়, কি বলা হয়? তাহলে এই মলিকুলের মধ্যে আছে পোলার আর নন পোলার, কি বলবো? তাহলে অ্যাম্পিফাইল। এবারে এই জলেও একটু একটু আর অর্গানিক সলভেন্টও একটু একটু করে করে এই কি করে, মানে ইটস এ ফ্যান্টাস্টিক প্রপার্টি, অ্যান্ড দ্যাট ইজ হাউ ইন ফ্যাক্ট ইউ ক্যান থিঙ্ক অফ, উই ক্যান রিপ্রেজেন্ট লাইক দিস, ইটস এ মলিকিউল। There only science starts. What happens? See, I'll tell you. In research, একজন কিছু রিসার্চ করলো, হি উইল লিভ হিজ অর হার নলেজ, পরে যে শুরু করবে তার যাত্রাপথ শুরু হবে ওইখান থেকে। আবার হি অর সি উইল টেক সায়েন্স ফরওয়ার্ড। আবার সায়েন্স অ্যান্ড টেকনোলজি দে উইল মুভ সাইড বাই সাইড। যত বেটার সায়েন্স তত বেটার টেকনোলজি, আর যত বেটার টেকনোলজি তত বেটার সায়েন্স। এইভাবে হাত ধরাধরি করে চলছে। তো হলো, তো once we get such molecules, what can happen? We believed, one scientist, there are many scientists here, with whom we have collaborations, we saw this kind of behavior, that this is forming a colloidal suspension in mixed solvents. We need not go to the details, but you will see what it is. Just see under microscope. এই যে Leeuwenhoek, same thing we did here at the Midnapore University, and then see spherical objects. আর দেখতেই পাওয়া যাচ্ছে, তোমরা যেমন সেল মেমব্রেন, সেখানে যেমন মেমব্রেন গোল করে হয়, তো মলিকুল তো ছিল, টুক করে এরকম হয়ে গেল কি করে? ইটস বিকজ অফ ইটস অ্যাম্প্লিফাইড নেচার। আবার দেখো, বাইরে জল, ভেতরেও জল, অথচ ইট ইজ ফর্মিং এ কাইন্ড অফ মেমব্রেন স্ট্রাকচার, ভেতরে ফাঁকা। তো উই হ্যাভ টু প্রুভ হোয়াট ইট ইজ। অ্যাজ ইউ ক্যান সি, ড্রাই করে দেখছি, হ্যাঁ তাও যেন উঁচু 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 মতো আছে, তার মানে কি ঠিক করে 3D সব, 2D হলে 3D, দেখছো না 3D বলের মতো পড়ে আছে। And then you can see this electron microscope, হ্যাঁ, এটা হচ্ছে SEM and this is TEM. আর এই যে মেমব্রেনের কথা বলছেন, মেমব্রেন দেখতেই পাওয়া যাচ্ছে, and we can see the nano dimension. And then, like, as you can see, we have like proposed a model that this amphiphilic molecule can form monomer and then dimer and then bilayer and then vesicle and then এই যে bilayer vesicle তৈরি হয় ভিতরে ফাঁপা. So what? Can we entrap something inside also molecules? How to see that? Well, there are techniques to see that, like fluorescence microscopy. If there is something inside, you can see those. I'll show you one picture. Just see. ভিতরে ঢুকে গেছে, দেখছো না? Starting from Bixin, Bixa plant, দেখো এই molecule which is self-assembled, formed vesicles, তার মধ্যে ঢুকে গেছে, এবং এই যে বিভিন্ন ফ্লোরোসেন্ট মলিকুল, তার মধ্যে একটা জিনিস কিন্তু ভেরি ভেরি ইন্টারেস্টিং, দ্যাট ইজ ডক্সোরোবিসিন. ভগবান ভালা করে কারো জন্য ক্যান্সার না হয়, আমরা ওষুধ দোকান থেকে ওই যে ডক্সোরোবিসিন কিনে এনে দেখেছি, সেটাও ঢুকে যাচ্ছে, ঢুকে যাচ্ছে. এবারে যে ঢুকে যাচ্ছে তার বিশাল সিগনিফিকেন্স, বিকজ ইফ ইউ ইউজ সাম কেমোথেরাপিউটিক ড্রাগ ফর দ্য ট্রিটমেন্ট অফ ক্যান্সার, it should not affect the other cells. So the challenge is we have to deliver the drug to the targeted site, correct? যেখানে ডিজিজটা হয়েছে. So now this one can act as a drug delivery vehicle. So if scientists are there, you know, he's listening to my talk, he is very much interested in our compound, that sir, why don't you, because he was a student when I was like teaching there, so you know, this Dr. Antonie is there, so he's very much fascinated by your work, because he is expert in this anti-cancer and then other biological experiments. So today only we spoke to each other, and then definitely I'll speak after this lecture also, so that we can, you know, take the science and the chemistry forward, so that we can do something for the society, for the benefit of the mankind. Okay, shall I continue further? Shall I continue? She will say, continue. Okay, shall I? Okay, good. So they are enjoying this. Okay, then as you can see, now I can justify that yes, this is published in the leading journal, First Physical Self-Assembly of an apoptotic Bixin in aqueous liquids, and its antibacterial activity dekhechi, so it was published. এবার যদি দেখি যে হ্যাঁ, there are hundreds and thousands of such molecules. If we think of triterpenes, they contain 30 carbons. Means ওই যে C5 ইউনিট যদি 6 দিয়ে গুণ করি C30 হয়ে যাবে. তাহলে এই যে এরকম ধরনের ডজনস অফ মলিকুল, ডজনস অফ এক্সাম্পলস আর দেয়ার. আর একটা এক্সাম্পল দেখাবো, তারপর শেষ করে দেবো, যে হ্যাঁ, অর্জুন গাছ. কতজন দেখেছো অর্জুন গাছ? অনেকেই দেখেছো. এই দেখছো অর্জুন গাছ, সব মিলে যখন চেরাই করা হয় সডাস্ট, এটা কি করে? পুড়িয়ে ফেলে রান্না করার জন্য. আমরা বলি প্লিজ ডোন্ট বার্ন, we want to do some chemistry, and medicinal use of this plant is known since the Vedic ages as a cardiac tonic. This is perhaps the best medicine for the treatment of heart diseases. এটা একেবারে অথর্ববেদের সেই সময় থেকেই লোকে জানে. হ্যাঁ, তারপরে for the treatment of low blood pressure, blood descent and so on. And we got this fantastic molecule again, arjunolic acid. Again, nanosized, 1 carboxy, 3 hydroxy, 1.35 nanometer. And as you can see here, this also forms gel and then vesicles. এবং এই যে ভায়ালটা হেমিওপ্যাথিক ভায়াল, উল্টা করে ধরেছি, পড়ছে না. দেখো দেখো দেখো, এই যে অর্জুন পাতা দিয়েছি, এটা এই যে ছিপিটা এই দিকে উল্টা হয়ে গেছে, পড়ছে না, ট্রান্সপারেন্ট, because this is formed as gel. And then as you can see under microscope, again vesicles, and then under optical and then ACM, as you can see vesicular structures and membrane thickness, AFM proposed model as before, densely packed vesicles, and it forms the gel. This is the mechanism, and you can see in this case also it can entrap anti-cancer drug. And to tell you frankly, arjunolic acid, the compound that we isolated, that itself has some anti-cancer activity. In addition, it can carry anti-cancer drug. দুটো, যে ক্যারি করছে তারও অ্যান্টি ক্যান্সার, যাকে ক্যারি করছে সেও অ্যান্টি ক্যান্সার. ইটস এ ভেরি ইন্টারেস্টিং কম্বিনেশন. শুধু তাই নয়, there can be synergistic effect. There in fact, Dr. Shantanu Kor, he can perhaps contribute, যে synergistic মানে কি? মনে করো তুমি এক পা ও এক পা, তো ঠিক আছে চলছো, কিন্তু যদি এমন হয় যে হ্যাঁ this multiplies, that is called synergistic effect, মানে it enhances not A plus B plus something even beyond than individual contribution, that is called synergistic effect. So we are interested in that because the molecule which is forming the vesicles, which can be used as a drug delivery vehicle, that itself is anti-cancer. And also, as I told you, this is plant-based, not synthetic. Why the whole world is looking at this? Why? Because Dr. Kaur Mahapatra knows very well, in most of the cases, the vesicles that people use is synthetic molecules, like polymers, the polymer chemistry. They synthesize and then they try to get some vesicles. But here the naturally occurring compound, they are forming vesicles. So this is the advantage. So we would like to focus in that direction in the future research. So as you can see, this is again published, and also we got patents on this. In leading journal, this was published. So that is how the chemistry goes on. There are other molecules as well, like from a talk to গাছের ছাল, সেখান থেকে butyllonic acid, that itself is again anti-cancer, and well, that also forms fibers and gels. Leading publications is a ursolic acid from Plumeria rubra, that also forms vesicles and tubes. We can derivatize, we can get the gels and also fibril network. As you can see, this is the gel, and this was featured in the cover page of the journal Language. This is American Chemical Studies Journal. So I'll not go to the details. I am almost at the end of my lecture. As you can see here, that if you can put some functional groups, and then this can even form on thermochromic material. So advanced functional material, how it is. As you can see here, that this is yellowish color, but once it forms a gel, this is deep red color. And then we are heating with a hot air blower. When we are heating, there is color change. As you can see, হিট করা হচ্ছে, এখানে রেড, একই ভালের মধ্যে যে গলে গেল, দেখো হলুদ করে পুরো ইয়েলো, আবার রেখে দাও এরকম। তার মানে কি, যখন জমে যাচ্ছে লাল, আবার গলে যাচ্ছে হলুদ। সো ওয়ান ক্যান সুইচ thermochromic material, so advanced material. So we have published again, we have got a patent on this also. So that is how the science advances with different molecules, examples from plants, and so these are featured in frontispiece graphics and so on. And also, this IUPAC, the full form. Absolutely correct, absolutely correct. They invited me for delivering a lecture, which was organized, the symposium was organized at Bangkok, Thailand. I delivered the lecture, and after the lecture, they published my lecture in their journal, Pure on Applied Chemistry, as you can see, in the year 2019. Thank you very much. So, I hope you have many questions. So if you have any question, you can raise your hands, and then I'll try to address whatever I know.
So my question is, how do you find the formula of any compounds?
Fantastic question. How do I find? It's very difficult analytical techniques. First of all, in any chemistry laboratory, we do thin layer chromatographic analysis.
Okay.
That is analytical technique. And then we go for column chromatography, that is purification technique. So that there will be n number of components, but the compound that we think will be of our interest, we isolate that compound. And then first thing we do is UV, whether there is any chromophore. Then we do IR, means infrared.
Okay.
What are the functions that are present? Then we do NMR, like proton NMR, carbon-13 NMR, and then advanced NMR, so that we will know the connectivities. And then mass. Suppose carbon, hydrogen, nitrogen, oxygen, so it will have a mass. So we will do mass spectroscopy. Okay. And then if you can do a single crystal, then we will do X-ray analysis. so that we'll get the molecular structure. The arjunolic acid structure, that was the X-ray structure.
Okay.
The question that arises is, molecules do exist, right? Molecules exist, right? Yeah, molecule molecules exist, right?
Yes.
Molecules exist, right? But can you see them?
No.
But how to see them? Absolutely correct. Absolutely correct. We can see under electron microscope, or the better option is X-ray crystallography. So one can see molecules. Molecules do exist because one can see them. But how? Not in open eyes, because here the UV visible length, that is, we can go up to like 400 or like lowest 200 nanometer, not below that. But for that you need some lower wavelength frequency. So naturally one has to go for electron microscopy or even X-ray. Not so transparent mone hobe, তাই না? Very good question. Thank you. কি নাম তোমার?
Debangana Kandar.
Thank you.
Kontai Hindu Girls School.
Wonderful. Thank you. All the
Thank
best.
you, sir.
Anyone else? You can raise hands. Okay. Please introduce yourself. Name and school name.
My name is Songlab Das and school name is Contemporary Institution. স্যার আপনি বললেন যে বিক্সিনের মধ্যে ইন্টারমলিকুলার স্পেসেস আছে যেটা ইউজ হয় ড্রাগ ক্যারি করার জন্য। এবারে কিন্তু ড্রাগটা যে স্থানে রিলিজ হবে সে রিলিজটা হয় কী করে?
Absolutely correct. Fantastic question. That is again a challenge. First of all, perhaps Dr. Kormahabatra can answer that. So the science goes beyond boundaries. Fantastic question. I'm very happy that you are curious on that. So first, yeah, okay. Oh, please. Yes. Good.
যে কোনো সেলের কাছে ঠিক আছে শুনতে পাবো। যখন কোনো সেল বা মাইক্রো অর্গানিজম যাই হোক না কেন, প্রত্যেকের বাইরে কি থাকে? সেল থাকে। এবং সেলের যে মেমব্রেন বা তোমার সেল ওয়াল, তার স্ট্রাকচারও কিন্তু ভেসিকুলার ফর্ম। লিপিড, প্রোটিন, লিপিড আমরা জানি লিপিড বাইলেয়ার থাকে। তো লিপিড আর একটা লিপিডের সঙ্গে তুমি যদি এক ফোঁটা তেল দাও আর এক ফোঁটা তুমি ধরো আর একটা কিছু তেল দিলে, দুটো কোম্পানির তেল, কি হবে? মিশে যাবে। তো সিম্পল ওই একই টেকনিকে দুটো ভেসিকল একে অপরের সঙ্গে কিন্তু খুব সহজেই জুড়ে যায়। তো যখনই তোমার জুড়ে যায় তখন ভেসিকল ফর্ম করে সে তখন ভেতরের জিনিসটা এক জায়গায়, মানে আমি একটা সেল নিলাম এখানে একটা, এখানে আমার ড্রাগটা বা ভেসিকলটা রইল, দুটো যখন ফিউজ করলো মানে দুটো যখন জুড়ে গেল তখন এইভাবে খুলে গেল দুটো দিয়ে এর ভেতরের জিনিসটা ওখানে চলে। এটা হচ্ছে কি খুব সহজে বলার মতন মানে উপায়। আরেকটা যেটা যে টার্গেটেড যেটা হয় অনেক সময়, যে টার্গেটেড ডেলিভারি আমরা করি, কালকে বোধহয় তানিয়া ম্যাডাম কিছু ওই ধরনের কথা বলছেন বা গৌরীশঙ্কর স্যার কিছু বলেছেন নিশ্চয়ই আশা করি। তো সেখানে কি হয়, রিসেপ্টর জানো তো, মানে সেলের বাইরে যে মলিকুলগুলো থাকে, তখন আমরা ওই ভেসিকেলের সঙ্গে একটা কিছু অ্যাডিশনাল দিয়ে দিই যেটা কিনা লিগেন্ড হিসেবে কাজ করে। তখন সেই রিসেপ্টর লিগেন্ড ইন্টারঅ্যাকশন দিলে রিলিজ হবে। ঠিক আছে, মানে সহজ করে যতটা পারলাম আমি চেষ্টা করলাম।
নাহলে পিএইচ হতে পারে, পিএইচটা হতে পারে।
পিএইচ একটা জিনিস, ইলেকট্রোস্ট্যাটিক বন্ডের অনেক কিছু ব্যাপার রয়েছে, অত বলতে পারবো না।
9, 30, 20 আর 19 নম্বর যে বন্ডটা আছে সেগুলো ফ্রি বন্ড আছে। তো এবারে সেইগুলো কি কোনো বন্ড গঠন করে, সেই যে রিসেপ্টর বা লিজেন্ড গঠন করে সেগুলোর সাথে?
এটা স্যার বলতে পারবে।
হ্যাঁ, আরেকবার বলো। হ্যাঁ, দেখি।
9, 13, 20 আর 19 যেগুলো আছে সেগুলো ফ্রি আছে।
আচ্ছা,
বন্ডগুলো। এবারে তাহলে
ফ্রি মানে সিঙ্গেল বন্ড আর অন্যগুলো ডাবল বন্ড।
না, ডাটা ফ্রি মানে কোনো গ্রুপ নেই বা কোনো মলিকিউল নেই, ফ্রি বন্ড আছে।
আচ্ছা।
সেগুলো কি এবার লিগেন্ড গঠন করে সেগুলোর সাথে, মানে কোষে যখন যা রিসেপ্টর সাথে কি লিগেন্ড গঠন করে সেগুলো?
তুমি যেটা বলছো সেটা হচ্ছে লাইক there are two kinds of transformation অথবা interaction. One is chemical transformation. এবারে যদি ফর্ম করতে হয় তাহলে কিন্তু এটা কেমিক্যালটা কিন্তু দুম করে হয় না, তার কারণ কি তার জন্য একটা এনজাইম দরকার ইন দ্য কেস অফ ফিজিওলজি। whereas আমরা ল্যাবরেটরিতে করতে পারি বিভিন্ন ধরনের রিয়েজেন্ট অ্যাড করে, কিন্তু আমাদের শরীরের মধ্যে তো সেরকম ধরনের কোনো রিয়েজেন্ট নেই। তাহলে কি এই ট্রান্সফরমেশনগুলো হয় ইন দ্য প্রেজেন্স অফ সুটেবল এনজাইমস, কারেক্ট? ফলে কেমিক্যালটা আলাদা। আর তুমি এটা বলছো যে নন কোভ্যালেন্ট যেটা, সেটা কিন্তু হতেই পারে এবং সেইভাবেই কিন্তু এই কেমিস্ট্রিটা হচ্ছে, সেটা না হলে হতো না। দ্যাট ইজ হোয়াই ইট ইজ সো ফ্যাসিনেটিং যে হ্যাঁ, ইট হ্যাজ গট both the kinds of groups, polar as well as non-polar, like band, জলে এবং ডাঙায়। এটা অ্যাম্পিফাইল, and that is why it assembles. ঠিক আছে না? ভেরি গুড। Anyone else? খুব ভালো প্রশ্ন। I am very happy that they have understood so much. আর কেউ? Perhaps.
Thank you, sir, for your mesmerizing speech and a very enlightening session. Now we will have our second lecture, that is by Professor Probal Choudhury, and he will be coming to the seminar hall shortly. So we are requesting our students to maintain discipline and sit in the seminar hall, that we will soon have our second session. Please be seated, everybody. You are requested not to leave the seminar hall. It's a wonderful moment for us as we have Professor Probal Choudhury with us. We will soon start our second session. Professor Probal Choudhury, a distinguished professor at the Theoretical Statistics and Mathematics Unit at Indian Statistical Institute, ISI, Kolkata. Professor Choudhury is renowned for his work in statistics and mathematics, and today he will present a fascinating talk on shape of the earth and the method of least squares. I'm requesting Professor Choudhury to kindly come on the stage. Now I'm requesting our scholars to kindly felicitate him.
Thank you, sir. Professor Probal Choudhury is a professor at Indian Statistical Institute and postgraduate education from the same institute during 1980 to 85 and did his PhD at University of California at Berkeley during 1985 to 1988. He is a recipient of C.R. Rao National Award in Statistics, B.M. Birla Science Award in Mathematics, and Shantiswarup Bhatnagar Prize in Mathematical Sciences. He is a fellow of all three National Science Academies in India and a fellow of Institute of Mathematical Statistics in the US. His research interest is in mathematical statistics as well application of statistics in science and engineering. Now what you said, please. Okay.
There, okay. So that I can put. Okay. Restart. Okay. So it's still morning, I guess. So good morning to all of you. Now, those of you who are at the back, can you hear me clearly? Because I see some empty chairs here. So if you want, you can move forward, so that you can hear me clearly. Okay. Now, let me set the time. Okay. So, you have been already exposed to several lectures by now. Can you tell me what are the topics that were covered in the previous lectures? I would expect people to speak here. I am not going to be the only person speaking here, okay? So, I'm asking a very simple question, okay? So, what are the topics that you have been taught so far in this camp? Yes? Say it a little loud so that I can hear you and others can hear you. Yes? Now, even without microphone, if you say a little loud, I think it will be all right.
Photochemicals from plant and its effect on sustainable development.
Anything else? I mean, that's the only thing.
And its effect on cancer. How to use it on cancer immunology treatment or
So those are all chemistry and biology, right? Anything on
Yes,
physics or maths?
Astro
Yes?
astrophysics.
In astrophysics, what did you learn about in astrophysics? What was the lecture about on astrophysics?
Sir, in the lecture on astrophysics, we came to know about the basics of astrophysics and cosmology. We also got a brief description of the gravitational waves and all that, and pulsars, rays, and how can we measure the mass of the sun, and how we also learned one interesting fact that we are actually, whenever we are looking at the night sky, we are looking at the past, because the light takes some time to come, and it is the
Why
older
it
light
is always the past?
Yes, sir, it is always the past, because like the light takes some time to come. It maybe, for example, for our sun it is 8 minutes and I guess 19 seconds.
It's
something.
only a few minutes.
Yes, only
but
a
for
few
a
minutes. Yes, sir, but
star far away,
yes,
it
sir,
may be
like
a few
yes.
1,000 years or so.
Light
right?
years and all that. So if, for example, Proxima Centauri, that is the second nearest star, it is about, I guess, 1 or 2
So
light years away.
You said something that you have learned how to measure the weight of the sun, right?
Yes, sir.
What is the method? I mean, how
So
do
we can find out the radius, then we can calculate, then from the light coming we can do the spectroscopy, then we can find out about the rough composition of the sun. I mean, that is what I understood. Actually, it may be wrong. So, and after that we can calculate the mass of the sun.
Okay, okay, good. Okay. So let me ask you a different question, okay? So all of you are science students here, right? So I will ask you to name what you think is some of the greatest discoveries in science in the last, say, 30 years or 40 years, something like that. 1 or 2. Anything that comes in your mind. What you think is the greatest discovery in the last, say, 30 to 40 years?
Sir, discovery of artificial intelligence.
Why do you think so?
Because it is very essential and helpful for our modern life.
In what way?
It makes our difficult problem easy, and it can solve.
Give an example. Give an example.
If we look at the computer, it can solve many problems more faster than us, and
no, that is computer goes fast in computation. Okay, so it doesn't really solve the problem. Okay?
It like artificial intelligence have much better memory, and
it's intelligence, right? We are not talking about memory. Memory is a different thing. Okay, why artificial intelligence? By the way, do you know anything about the last Nobel Prize in physics? It was given for what? It is related to what you just said. It's for artificial intelligence and the application use of physics in artificial intelligence. That's how it was given. Okay, but give a very important example of artificial intelligence that we all use. Any example? There are many. Give me one example where we all use that.
we can use Meta AI in ChatGPT.
ChatGPT, but we don't use that all, right? Somebody, even your parents or grandparents are using something.
Yeah, no.
So something very simple. What about this device? Is artificial intelligence used there?
Phone, mobile
Yeah,
phone.
where is artificial intelligence used there? You know that you all use Google, right?
Yeah.
And you know that Google translates from one language to another language.
Yes.
How is it done?
It's because of artificial intelligence.
You see, it uses artificial intelligence. Okay. So also, any other application? Somebody else?
Sir, we know the many domains of AI, like you just said, that comes under natural language processing, which is also used by Siri, Alexa and Cortana. And however, we can also see, we have seen that if we search some kind of items in Google, we often see it on other browsing websites and other social media websites also. So that is also a kind of deep learning, I guess, where the machine or the AI enabled machine can recognize our patterns.
What is deep about deep learning?
So the deep about deep learning is that it extracts the big data and it shows and trends, it amplifies our trends, like our preferences during summer and winter.
No. That word deep is not because of that, for some other reason. Okay, you learn it. Okay,
Yes,
you know, you have heard about neural net?
Yes, sir. Neural
And
network,
you have probably seen pictures of neural net, right? And there are several layers.
Yes,
okay?
sir. Yes, sir.
So deep learning is essentially a very complex neural net. Okay, and it has too many layers. So that's why it's called deep, because you go deeper and deeper through the layers. Okay,
Thank you, sir.
it's just a algebraic fact or a mathematical fact. It has so many layers. Okay. Anyway, so that's about science today in some sense. Okay, you're right. That's one of the prime things. But if I ask you another, that is one example. I asked for two. So what will be a second most important invention, application, or discovery in science that affects our life? Something in life science? So that is related to physics, computer science, something in life science?
Sir, genetic engineering?
Okay, but something, is that affecting your life every day?
No, that is not.
So something that affects your life every day? Is genetic engineering affecting our life every day? It's not.
So maybe it is because, I mean, in the fields of agriculture I am seeing.
Yes. So how is it affecting your life through agriculture?
Sir, by if we use many kind of varieties by hybridization and genetic enhancement, we can cure some diseases of wheat and rice, thereby increasing their production.
Also, I mean, lot of the vegetables, you see
Yes,
vegetables round the year these days.
Yes, sir.
Like
So
when you want to
nowadays-
buy tomato, it's not only in winter, right? I mean, throughout
sir.
the year. So these are all genetically engineered varieties. Okay. Anyway, so that's about science today. Okay. So what do you think was prime science, say, 200 years ago or 300 years ago? What was major activity? So 200 years ago, 300 years ago, the great scientists at that time, who some names? So we are in the 2000. So if I go back 300 or 400 years, that's 1600, 1700, some great scientists. Say in 1600, some names of great scientists. Yes?
Sir, Newton maybe?
Yes, Newton. Newton, you have any idea roughly the time when Newton lived?
I think from 16th to 17th century.
Yeah, it was, well, it is 1600, so it is 17th to 18th. It's up to 18th century, 17th to 18th century. So Newton, okay? And what was Newton's main interest?
To discover what was not still
That is
discovered.
the interest of every scientist, right? Not just Newton. But specifically for Newton, what was he interested in? Why was he inventing so many laws of physics? I mean, what was his main interest?
I think he was maybe in search of.
So we read about Newton's laws, right, in school.
Yes, sir.
But what made him discover those laws? What was the thing that was motivating him?
I think he wanted to discover that what's happening in its surroundings.
Yeah, be more specific. Was Newton inventing the laws of motion because you are rolling a ball
Sir,
on the
about
desk
gravity.
and he was interested in that, or what?
About gravity, sir?
So it was the motion of the various planetary objects.
yes, sir,
Okay,
Newton's
that's what
motion
motivated
of
him.
laws.
Okay, so we will talk about some stories related to that time. Okay, all right. So let me start with the story. So you probably don't know the name of this person, John Riker. He was a French astronomer. So French astronomer should be in France, okay? Whereas he was in South America in 1672. So what would a French scientist would be doing in South America in 1672? What is your guess? Well, I think it's probably a difficult guess. Okay, so he was involved in a project which is something like mapping the sky in the southern hemisphere. So he went to South America. Okay, so Riker went to South America, and in those days the only clock was pendulum clock. They didn't have the fancy clocks that we use today. Okay, so Riker had a pendulum clock. In fact, he had a pair of pendulum clocks which were calibrated in France, and he was carrying them, and he found that when he was in French Guiana in South America, that he was losing 2 minutes 28 seconds every day. Okay, so his clock was running slow. He observed that compared to the local clock. Now, what do you think is the reason? Why would a pendulum clock? Are you all familiar with pendulum? And you know the laws of motion of a pendulum, right? And what is the formula, or what is the equation for the pendulum's motion? Yes? T equal to? Okay.
T
so
is
you
equal
know
to 2
that.
pi to del by g.
Okay, so you know that. Okay. So why do you think that pendulum clock was going slow or losing 2 minutes 28 seconds every day? When he moved, he calibrated them in France, in Paris. So it was perfectly all right in Paris. But when he moved it to French Guiana, it was going slow. Why? Yes?
Due to the change of gravitational acceleration.
Yeah, so acceleration due to gravity. But is it because the acceleration due to gravity was more or less there?
There is more.
It will be more. If it is more, then what will happen to the time period according to that equation?
It will become, the time period will be slow.
Time period will be slow. No, time period will be longer or shorter?
Shorter.
It will be shorter, then it will run faster, right?
Yes.
So what is the correct answer? What happened to the acceleration due to gravity when you move from Europe to South America?
It will decrease. Increase.
It will increase or decrease?
Increase.
If it increases, then time period will be
decrease.
So then it will run faster. So then it will not run slow. Acceleration due to gravity will decrease.
Decreases so that the time period increases.
Time period increases, and so the clock runs slow, right? Now, why would the acceleration due to gravity be less in South America compared to Paris? Longitudinal or latitude? I mean, why? How would longitude, latitude affects acceleration due to gravity? So if you are in South America, you are closer to the equator, right? Compared to Europe. That's basic geography. So as you move from Europe to South America, you are getting closer to the equator.
Change of omega in different radius.
Change in omega. What is omega?
Omega angular velocity.
Angular velocity of what?
Of Earth.
Angular velocity of Earth is causing the difference in acceleration due to gravity between Europe and South America. Is that right, or there is some other reason?
Yes, it is right.
Yes? Some other reason? Yeah, what do you think?
Sir, actually I think that, sir, I may be wrong. So I think that he's saying it correct, but I think there is cos theta involved in it. I mean the angle with the equator. And as South America is near the equator, so the
acceleration due to gravity on Earth will depend on what? Suppose Earth is a complete or a perfect sphere like a football.
Okay.
Now then if you move at different parts of Earth, will the acceleration due to gravity be different at different parts?
No. If it is a perfect
why do you think it is not different in that case?
Because the radius is same everywhere.
The radius is same everywhere. The distance from the center is same everywhere.
Yes.
So what is happening that is causing this difference in the acceleration due to gravity?
The change in radius, we can say.
So what? I mean, so explain a little more. That if I look at Earth, what will happen when I move to equator from Europe?
Sir, actually it is in geoid shape, so the middle portion is bulging outwards. So in that case, the radius of the equator, if we say, it is more than that of the pole. So in that
So,
way, the G
so
value
you
will be
understand
less.
what he is saying? Okay.
Yes, yes.
So it's like an ellipsoid. Okay.
Yes, yes,
So
ellipsoid.
because it is like an ellipsoid, as you go close to the equator, the acceleration due to gravity will be less. And that will have an effect on the time period. Okay. Now, this is something that is very obvious to you. Okay. But it was not so obvious to people in the, sit down. It was not so obvious to people in the 17th century. Because they used to think that Earth is probably like a football. Okay, that was their idea about the shape of the Earth. And today, if I ask you to verify what is the shape of the Earth, how do you do that? How do you find out what is the shape of the Earth? What things that you have available to you today for that? Satellite image, right? That's the simplest thing, okay? But in 17th century, they didn't have that. But they could feel from this that there is something that indicates that Earth is probably not like a football. Okay? They used to think originally that it is like a football, but it's not like a football. They realized that from this fact, that if I take a pendulum clock that is calibrated in Europe, if I take it to South America, it will run slow, so acceleration due to gravity is different, and that can only happen if Earth has an elliptical shape. But now they wanted to verify it. Okay? So let me connect this problem with Newton. Okay? So this is Newton's connection with this problem. So Newton actually mentioned this problem in his book, Principia. You have heard the name of this book, Newton's book. Principia, he wrote it in 1687. It came out in 1687. Okay. What was the language in which it was written? Yes? Latin. Okay, so in those days, like all the ancient documents in India, they are in Sanskrit. So it was all in Latin in those days. Okay. So all scientific documents written by great scientists in the 17th century or 18th century, you'll find all of them in Latin. Okay. So Newton claimed that Earth's rotation around its axis made it an oblate sphere. Oblate sphere is like that shape, okay, that elliptical shape. Rotation caused flattening at the poles and bulging at the equator. So Newton was, it was an imagination of Newton, okay, because Newton didn't have a satellite image picture of Earth. So Newton had that observation, that is that your clock is running slow when you move to the equator. So the shape must be elliptic. So Newton thought that originally probably Earth started like a lump of clay or something like that, a soft lump. Okay. Now think about the way they make sometimes bread from the dough, big bread from the dough by tossing it using their hand. Okay, so they rotate it, right? And so what happens is that it gets flattened at the top and then it bulged out at the equator. So something like that was probably happening due to its rotation. It was a complete imagination. Okay? There was no proof of it. There was no way for Newton to immediately verify that. Okay? It was his imagination. But a lot of people did not think that is the reason. They thought that there must be something else. Okay? So anyway, have you seen any picture of Earth taken by a satellite? Is any satellite image of Earth? There are a lot in the internet, right? Okay. So I'll show you one. Okay. It looks like that. Okay. This is like how the Earth will look if you take a picture of it from a satellite. There are many in the net, you can find them. Now comes the question that, okay, so this is what the picture will be like if you take the picture of the Earth from a satellite. But in 17th century, when Newton was working, Newton didn't have such things available to him. So suppose you are at the time of Newton, okay? And Newton comes up with this theory that Earth is elliptic shape. That means near the equator it is bulged out, at the pole it is flattened. How do you verify that in the 17th century if Newton is right or wrong? Let me formulate this question in a slightly different way. Suppose I give you a piece of stone, okay? Now, a piece of stone is something like this, okay? Now, if a piece of stone I give you, it has a very irregular shape. Now, this is not even an ellipse, okay? It is a very irregular shape, but it is more an ellipse than a circle. That's all. So, it is more elliptic than a circular shape. Now, if I give you a piece of stone, how do you decide whether it is more elliptic or more spherical? If I give you just a small piece of stone, what will be your way of deciding? Is it more spherical or more elliptic? It's of course neither a perfect sphere nor a perfect ellipsoid, but if I want to decide that, how do you decide that? Yes?
Sir, we can measure the minor axis and the major axis and...
Right, very good. So for an ellipse, the major axis and the minor axis will be different, okay?
Yes, sir.
But for circle, there is no major axis, there is no minor axis. All axes have the same length.
Yes, sir.
So what you will do, you will probably put a measuring tape in two different directions of that piece of stone. And in one direction, you will get the length of the minor axis. In the other direction, you will get the length of the major axis. And from there, you will conclude. If in two directions, the measurements are very different, then it is more elliptic. If in all directions, when you measure the axis, if it is the same, then it is more like a sphere. Now, if I want to do that for Earth, think of Earth like a big piece of stone. How do I put a measuring tape around Earth or something like a measuring tape? Yes? Can I hear? So I am only hearing from one or two people. That's not nice. Okay, let's hear from some others. Okay, okay. I'll give you an opportunity later. Let's hear from some others. Can someone else try? Is there anybody else who wants to try this? So the question is this, that I have a piece of stone called the Earth. Okay? Now this idea of putting a measuring tape to find out the major axis and minor axis, how do I do that for Earth? Yes?
Sir, I may be wrong, but I think that we can prove it theoretically from angular momentum theory.
Angular momentum theory, how? No, I just give you a piece of stone. It's not moving. Think of Earth like a stationary piece of object. Okay?
Sir, actually there are many mountain and many holes in the earth, so that...
So it's very irregular.
Yes, sir.
Yeah, so it's neither a perfect ellipse nor a perfect circle. Okay? But roughly, just like if I give you a piece of stone, you have a way of doing that, saying that, okay, it's more like an ellipse. Okay, this one is more like a circle or sphere. Similarly, is there a way that, is there a way to do that for Earth? And in the 17th century, of course.
Sir,
Okay, anyone else has any idea? Yes?
Sir, I think that we can explain it by if we imagine an axis in the center of that geode-like particle, then if we measure the moment of inertia, then...
that will be too difficult, right? I mean, see, don't bring in motion, okay? Because measuring anything related to the motion of the Earth in 17th century will be very difficult, okay? So, let's think about as a stationary object, and I am just trying to see whether in different direction it has different circumference.
No, the Earth is rotating, though we can measure the velocity. Then we can measure the, it is come from moment of inertia. After the calculation...
How will you measure that? Okay, okay, you sit down. Okay, I'll give you the idea. Okay, so it's much simpler than what you are thinking. Okay, so you all know what is latitude. You already mentioned that, latitude, longitude. Okay, how does one calculate the latitude at any point on Earth? So, for example, this is a cross section of Earth, say. Okay, it's not so nice ellipse, but Let's say this is a cross section of Earth. So these points, like this is a point where the latitude will be, this is the North Pole. So latitude is what there? 90 degree. And this is at the equator, so the latitude is 0 degree there, okay? At any point in between, how does one find out the latitude? How does one calculate the latitude? It's an angle. So it's an angle between what and what? How does one calculate? Yes? 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 So that's a common mistake. It's not the latitude. Okay, so say it again what you are saying so that I can correct the mistake.
The angle between the equator and the
So the equatorial line or the equatorial
Equatorial
plane.
line.
So yeah, so that is this one, right? That is this line. So if I join this center C with this point A, I'll get the equatorial line. And
the point and the joining line of center and that point.
but you see, I have drawn this picture to calculate the latitude, and this is like from A, the equatorial point, and B, the North Pole. In between, I have altogether 9 pieces, each of 10 degree. Now you see, I am not joining these points with C. How are these lines drawn? What are those lines? And I am looking at the angle with the line, with angle with the equatorial line, with those lines. What are these lines? These are not lines passing through the center that you thought. You thought these are like, in case of a circle, that's how you calculate the latitude. But in case of an ellipse, what are those lines? What are those arrows? So, you know what is a normal? At any point you can draw a tangent, and orthogonal or perpendicular to the tangent there is a normal. So these are the normals drawn at different points, and they don't pass through the center. Okay? They will pass through the center if it's a circle, not for an ellipse. So that is how latitude is calculated. Latitude is the angle between equatorial line and the normal at that point. And the normal will not pass through the center unless it is a circle. Okay? Now that's first interesting point. So if you have record of latitude at different points, which they had in the 17th century, if you have the record of latitude, then you can find out what is the latitude of this point, what is the latitude of this point, like that. But then something interesting is happening here. See, I have moved 10 degree from A to A1. From A1 to A2 also I have moved 10 degree. From A2 to A3 also I have moved 10 degree. But the length on the arc, that's different. That will not happen for a circle. For a circle, if I move 10 degree at any place, it will be the same length, but not for an ellipse. So that's a substitute for your putting a measuring tape. So I can move from one point to another point on the surface of the earth, and then I move in latitude, and then the length that I calculate, or length that I can calculate, will tell me whether it is more like a circle or like an ellipse. Because for an ellipse, what will happen? As I get closer to the North Pole, the distance that I will travel when I travel through same amount in latitude, it will be longer or shorter. You sit down. So, for this picture, if I move from equator to the North Pole, so here is the equator and here is the North Pole. If I move from equator to the North Pole, if I travel the same latitude, do I travel longer distance or shorter distance? Yes? Yes? Longer distance. For circle it will be same. Now suppose instead of this shape, the ellipse is like this, then what will happen? If the ellipse is like this, if I travel 1 degree latitude at different parts of earth, as I get closer to the North Pole, what will happen? I will travel shorter distance or longer distance?
Shorter distance.
Shorter distance. So it depends on the orientation of the ellipse. Now that's a very interesting fact, right? So, sit down. So by finding out what is the arc length for 1 degree latitude at different points on the earth, I can figure out whether it is more like an ellipse or like a circle. It's a beautiful idea, okay? And scientists in the 17th century or 18th century decided to use that to decide what is the shape of the earth, okay? So here is some interesting mathematical equation. So let y be the length of 1 degree meridian arc centered at the latitude theta. So if I go back, so it's like this is, if I take 1 degree around this point, the length of the arc is here. Here all these arcs are 10 degree, okay, because there are 9 parts that I have taken, so there are each is of length 10, and in terms of latitude, each one is of 10 degree, but you see they are of different lengths. And here is the relationship. So if Earth is an ellipsoid, then the relationship between y and the latitude theta is going to be this. Y equal to some constant times sine square theta plus c, approximately. It's not an exact relationship, okay? So if it is an if it is like a sphere or a football, then what will happen to this equation? For an ellipse, that's the general thing, and for an, see, you can think of circle like an ellipse, right? So circle is like a special case of an ellipse, and the major axis and the minor axis are same. So what will, my question is, what will happen to this equation if I have, instead of an ellipse, a circle? What will happen to m in that case? So will y be different for different theta, or it will be same? For a circle, it will be same. So it cannot change with theta in that case. So then what will happen to m? No, y is independent of theta, and what will happen to m? How will, in this equation, y can be independent of theta? What should be the value of m in that case? M should be? No. See, this is an equation where y depends on theta. But if y is really free from theta, what should be the value of m that makes it free from theta? M equal to? Y will be, m will be what? Yes? 0, right. If m is 0, then y is a constant, correct? Because then y does not change with theta. Okay, so for a circle, this equation holds with m equal to 0. Now for an ellipse like the earth, what will be the value of m? Will it be positive or negative? It's not 0. It's 0 only for a circle. So for earth, this m will be positive or negative? Yes? Why positive? Yeah, sine square theta in fact we have here. So not even sine theta, we have sine square theta. But why you think that m will be positive for that shape? What is the correct answer, precise answer? You are right, m should be positive, but why? Because with theta increasing, y is increasing, right? So m has to be positive. Okay? Okay. So now you have a very well formulated mathematical description of the problem. So if I can take measurements on earth and you can calculate y and theta, then from this relationship, if I find out a positive m, then I will get the shape of the earth like what Newton predicted, and otherwise it will be more like a circle. And this ellipticity of earth, Newton defined like this, and Newton gave a value for this. We don't know how Newton put a value like that, because this m and c, Newton probably had some imagination about it. So let's ignore the third part. Okay. So now comes the actual measurement or data collection. Okay. So These French arc measurements were done in 1720. You see that the problem was first observed in 1672 by Riker. Then people were discussing it, and then in 1720, they took measurements over a range of 9-degree latitude in Europe. And they took several measurements, and they were trying to see whether as you move from equatorial part to the North Pole, as you move in the direction of the North Pole, whether you get longer arc length or not. Okay. Now, this project was led by these two people. These are father and son. They were in charge of the Royal Observatories in Paris. And their measurements and analysis actually did not support Newton. Now, let me look at that picture that I have shown you already. See, Earth is not really like an ellipse. Okay. So, if this is the shape of the Earth, and suppose you take some measurement somewhere here, and suppose you take some measurement somewhere here, your findings will be different, right? Because here, if I stand and take only 9-degree arc and I take measurements there, then it looks like more like an ellipse like this, right? Whereas if I am here, then it looks like the other way. So, because of the irregular shape, the first set of measurements they collected in 1720, that did not really confirm what Newton was saying, but people were not satisfied with it. They said that we need to collect more measurements over a broader range on Earth, and then only we will be able to settle whether what Newton was saying is right or wrong. Okay. So, you see, in 1735, they took a big expedition. Okay. So, a team of scientists went all the way to the, you know this place, Ecuador? It's a small country in South America. It's on the equator, that's why it's called Ecuador. Okay, and their capital is Quito. And another team that went close to the North Pole, that was Lapland in Finland. Finland is close to the North Pole. So there are two teams, and there are many scientists involved in that. And this expedition, why do you think this took them 1 year? Because they didn't have aircrafts to fly in those days. Okay, so they were traveling mostly on the land and water by ship, and it was a long process to reach South America from Europe. So you see, they took such a project at that time. So it just see how excited or how important it was for them. Okay, so at that time, this was like one of the most important problem in science. Okay, and it took them nearly 1 year to complete this expedition, and they collected measurements at different parts on the way. Now, the team that went to Lapland, that included, so this entire team that were involved in the expedition had many famous scientists from Europe. Okay, so one name I will tell you, the person who went to Lapland, the person who was leading the team that went to Lapland, he is a very famous Swedish scientist. And you know the different scales of measuring the temperature? What are the different scales? Celsius and Fahrenheit and Kelvin. Okay, so among these people, who is Swedish? Celsius, Fahrenheit, Kelvin? Yes, what is your guess? Huh? Fahrenheit was not Swedish, okay? This is German, okay? Celsius, okay? Kelvin was British, you know that, okay? So Celsius was Swedish, okay? And Celsius was leading that team. So it involved all those star scientists in those days in this project. Okay. And when they came up with the data, here is a picture of a person. See, this is from again 18th century, and in those days they didn't have these mobile phones with which you are taking pictures of all these things. Okay, so this was really a portrait drawn by an artist. Okay, and the name of this person, you probably don't know his name. His name was Roger Joseph Boscovich, and he was the person who compiled the data that came out of this expedition and tried to analyze it. And I will show you the table that he prepared. Okay, so here is the table that he prepared. So you see Quito, So the latitude is 0 degree and the arc length is this. Now can you read it from the back? What is written here? Arc length? Toises. Now it's a very weird term. You probably haven't heard this before. It was the unit of length that was used in France those days. Toise. Just like in Britain, the unit of length was feet. And now everywhere we use centimeter, meter and those things, okay? But in those days, in Europe, in France, that was the unit of length. And here is 1 toise is approximately 6.39 feet. So this was the arc length at different places, Cape of Good Hope, Rome, Paris and La Plante, okay? And you see the corresponding latitude. And so remember the equation? So the equation is this, y equal to m sine square theta plus c, and Boscovich took that sine square theta for different theta. Theta is here, the latitude, and he was multiplying that by 10 to the power 4. Why do you think he was multiplying that by 10 to the power 4? So a multiplication by a factor of 10 to the power 4 will make it larger, right? Why Boscovich was doing that? So sine square theta is a number between what and what? 0 and 1, right? It's a fraction, okay? So it's a small number. So sine theta itself is a fraction. So when you square it, it becomes even smaller. So compared to the arc length in toises, those numbers will be very, very small, right? So you will not be able to see the variation. That's why you sort of magnified it by that factor of 10 to the power 4. So this is Boscovich's table. So now it should be easy, right? You think that, okay, so I have, so in your equation y equal to m sine square theta plus c, what is y in this table? Which one is y in this table? Which column represents values of y? Sine square theta is there, that is sine square theta, but which column is y? Arc length, correct. So y is that column. So y values are there and sine square theta is there. So now you try to plot them in a graph sheet and try to see whether you get a line with a positive slope or not. Okay. Now you are not going to get a perfect line, right? Because it's only an approximation, and when you take measurements on arc length, I mean there is a huge measurement error involved because it's not so easy to measure the things, okay? So they got a picture like this, right? So each point here, this circle or dot here is a data. So there are 5 of them, and so it's like you take any 2, you get a straight line. But they are not lying on the same straight line. They are not all lying on the same straight line. So they get different equations. And they did not know how to sort of reconcile that. So they called it the problem of inconsistent equations. It's actually a term used by Boscovich. Boscovich said that, okay, I have the data, but I don't find them lying on the same straight line. That's not very surprising because of the measurement error and also the irregular shape of the earth. Okay, but then Boscovich decided something interesting. Boscovich decided that, okay, if I take a pair of points, then I will get a line, and I can calculate the slope of that line. So how many pairs of, so if there are 5 measurements, so there are 5 measurements here, how many pairs of line will be there? It's a small exercise in algebra. 5 points, and you take a pair of points and join them, you get a line. How many lines will be there? What is that? 5C2? What is the number? 10. So there will be 10 lines altogether. So Boscovich prepared a second table. So this was first table that he prepared, and Boscovich prepared a second table. You see that he is taking these pairs, and for each pair he is calculating something like a slope, and from there he is getting ellipticity, and except for one pair, that is the point 2 and 3, everywhere he is getting a positive slope. So it is more or less confirming what Newton thought, right? So everywhere out of out of 10, 9 pairs are giving you positive slope, but 1 pair is not giving. Okay. But then people were wondering that, okay, so if I have such a problem and I want to find a straight line that approximates those points, how do I do that? So that became a different problem, a mathematical problem for them. Okay. So by the way, you are all mostly in class 11, I guess. So have you done any experiment with pendulum yet? Probably not. You have done? Probably not. Okay, but you will be doing that. Okay. Now you told me a law of the pendulum, time period equal to 2 pi square root L by G. Now suppose you can do this experiment yourself at home. It is very easy. You just need to construct a pendulum, calculate the time period, so you just let it swing, and then you see what time it takes to complete one full swing. So you let it swing 10, 20 times and then take an average. So that's how you get the time period of the pendulum. And then you do it for different length. And you try to collect the data. So I did that experiment with the help of a student, and this is the data that I got. So here is the time period and here is the length. I don't have numbers here, that's not important, okay? So I don't have any figure or number in the vertical axis or in the horizontal axis, but this is just a set of dots that I have here, and so that's the law of the oscillating pendulum. Now, if I plot time period against length, that's not going to lie on a straight line. That's going to lie roughly on what kind of a curve? You look at the equation. What is the kind of curve they are supposed to lie on? It's the relationship between T and L. L is the length, T is the time period. Okay? So T is related to square root of L. So what kind of curve it will represent? Hyperbola? No? Parabola, right. So they will be lying on a parabola, but if I want to bring it on a straight line, what do I need to do? I should plot what against what? If I plot time period against length, I will not get them on a straight line. So what should I plot against what so that I get them roughly on a straight line? Yes? T square against L. Okay? So let's do that. So this is the parabola, and if I plot time period square, T square against length, then they should be roughly on a straight line. Now I have drawn a line like this. How do I get such a line? In some sense, that's like the best or the most reasonable approximation that fits the data. Now, how would one get such a line? You have any idea? So, suppose you actually do this experiment. This is a very simple experiment. You can do it at home. You collect the measurements and then draw this picture on your graph sheet, and you plot time square against length. So you draw this picture and then you get the set of points like that. By the way, if this is the law of the pendulum, why their points are all not lying perfectly on a straight line? What? Well, in case of Earth, it was a very irregular shape, and also there are a lot of measurement errors. But what is it that is causing these points to deviate from a straight line in this case? Why they are not perfectly on a straight line? That is the law of pendulum, and that we know, that we all know that is true. So why they are not lying on a straight line, the points? It is not. What is not same? Gravitation is not same. When you do this experiment at your home, I did it in my office. Instrumental error. But suppose I do this experiment in a very perfect condition by very skilled experimenters, will they still be lying on a straight line? What do you think? By the way, do you know how this law or how this equation of pendulum is derived? It's based on a particular type of motion. What is that motion called? It's oscillatory motion, but a very special type of oscillatory motion. Right. It's a simple harmonic motion. Now, What is the condition for a simple harmonic motion? What is the, when you describe simple harmonic motion, what is the first condition? It's on, no, it's before that. A simple harmonic motion is on what kind of path? What kind of path? Is it straight line or? It's straight line, right? That is the definition of simple harmonic motion that you have learned. But think about your pendulum. It's not moving in a straight line. But if the length is very long, then it's almost a straight line. So there is an approximation there. So even if your experimental devices are all perfect and there is no measurement error, still it will not be on a straight line because it is only, again, this is not an exact equality, right? This is only an approximation. Now, this is always true for most of the scientific laws that you learn in physics or chemistry, okay? They are only approximations to the reality. And the approximations are simple, so we use them, okay? So, that is why they don't lie on a straight line. So, now the question is, how do I get them on a, how do I get a straight line out of this scattered set of points? What will you do? Suppose, I ask you to, so for example, one of the purpose of doing this experiment and doing all this calculation is to find the value of the acceleration due to gravity, right? You know that, okay? So there are a bunch of constants. So if I look at t square and this, then the equation is t square some constant times L. And so from that constant, I can get the value of G. So one purpose is to calculate the value of that constant. And how do you calculate the value of that constant if they don't lie on a straight line? If they all lie on a straight line, then it is easy. It is the slope of that line. But if they don't lie on a straight line, how do I find out the value of G? So you can't do like Boscovich, that you take pairs of points and then you get a value of G. Because then you will get multiple values of G. Of course, they will probably not differ very much, but that is not nice. So how do I get one value of G or one straight line out of such a data? What will be your idea? Yes? You don't have any idea? Okay, let's wait for it. So, just hold on to it for a moment, okay? So, I have drawn a line here, but, even if you don't know, suppose you have these points on your graph sheet, what will you do if somebody asks you to calculate the value of G? What will you do? Just use your common sense. So every pair of point you will join, then what? I will calculate the slope, but then there will be several slopes. What will you do after that? You will take an average. Yeah. That's a good idea, okay? But whether that's the best you can do or not, we will learn, okay? But that's a simple idea, okay? Nothing wrong with that, okay? So there is variation in the value of slope that I get. So I calculate all of them and then take something like a simple average. Or you can just use a simple sketching of a straight line through it. That's another thing. Anyway, but let's see how this problem was handled by scientists in the 18th century. You sit down. Okay, so let's come to 1792. That's almost end of the 18th century. So this problem that I was talking about, that started in 1672. So it's already 100 years since then. Okay, so in 1792, after the French Revolution, France and many other European countries decided to switch to a new system of measurement which you use today, the metric system. Now in the metric system, the unit of length is meter. Why they wanted to do that? Because see, in France they are measuring the length in toys. In Britain, England, they are measuring it in feet. And in other parts of the Europe, they are measuring it in some other units. And when the scientists were sharing the data, that created a lot of confusion because of the conversion factors, okay? So they wanted to standardize it. And they decided to have a convention in Paris where they decided about this metric system. And in order to define 1 meter, they chose this. So 1 meter was defined to be 1/10 million of a meridian quadrant, which is the distance from the equator to the North Pole. So if you look at the meridian quadrant, what is a meridian quadrant? You look at the Earth and you start from the North Pole and go to the equator. That's one meridian quadrant. And you take one meridian quadrant, cut it into 10 million equal parts, and each part will be taken to be 1 meter. That's how originally meter was defined. Okay? Now, of course, the meridian arcs are not of the, or meridian quadrants are not of the same length everywhere because of the irregular shape of the Earth. So they decided to take the meridian quadrant that will pass through the Paris. That was what was decided in that convention. Now, let's go back to the equation. So you know at any point theta, what is the length of 1 degree arc? So if I want to calculate the length of the meridian quadrant, how would I do that? I will have to calculate the length at different points and then add them up. Now if Earth were a sphere, this would have been a very simple problem because I could take the measurement at only one place and then multiply by 90 degrees. Right? And that would have been very simple because of the uniformity. But because Earth is elliptic, I have to go through this exercise. So I have to use this equation to calculate the length at every theta, and from one place to another place, I will calculate it and then I will add them up. So now the question is, how would I use this equation if I don't have one straight line? So I need one straight line, right? Because once I have a single straight line, I have a single value of m and I have a single value of c, and then I can calculate the value of y for different theta, and I can add those values of y to get the length of the meridian quadrant if I do it from 0 degree to 90 degree. So it was this famous French mathematician, Legendre, you probably have heard his name. He was associated with this French commission who was charged with the measurement of a meridian quadrant, and Legendre invented a method. I will show you the method. This is the picture of Legendre. So this is Legendre's method, okay? So you have these different points and they don't lie on a straight line. Now I want to find one straight line. So what I shall do is that for any straight line, I will look at this vertical distance. Okay? And how is this vertical distance calculated for a point x1, y1? This is this vertical distance, right? y1 minus mx1 minus c. If you take the absolute value, that is the distance, and if you square it, that is the square of the distance. Is that clear to everybody that that is the square of the vertical distance? So these distances that I have here, note that this is not the perpendicular distance. It is the distance in the y direction. Okay? Because if I draw a perpendicular, then the picture will look different. Here, it is a distance in the y direction. That's why you get it like this, y minus mx minus c. So if the point lies exactly on the straight line, this distance will be what? 0. So this difference will also be 0 because then the point will satisfy the equation of the line. Okay? So what Legendre said is that you square those distances and add them up and find the line for which m and c are such that this square, sum of the squares is minimum. Okay? Now, suppose you want to use Legendre's method for your pendulum problem. So you have collected the data. Now, for your problem, the problem is somewhat simpler because the c is not there. Why? Because the equation is t square equal to some constant times L. There is no intercept term, only the slope. So c is already 0. You don't have to worry about c. So for you, the equation is like this. y equal to mx. And since the line passes through the origin, finding the best line means finding the line with the best slope. Okay? So, for you, the minimization problem is like this. Now, how do you solve this minimization problem? So, when you do this pendulum experiment, you will get a bunch of values for x and y. And yi minus mxi whole square, what am I doing here? Do you recognize this expression? How do I get this? What am I doing here? Yes, sum, but before sum, I am expanding this square, right? So I get y square that comes here, then I get m square xi square that comes here, and then this twice every term that comes here. So eventually I get this. Now, I said the m that minimizes this, which is the optimal slope I call, is b by a. Why? How do I get that? So, this is what kind of an expression in m? It's a quadratic expression in m. How do you minimize a quadratic expression? You have learned this, right? You have a quadratic expression and you want to minimize that. How you minimize that? Yes? What do you mean by factorize? I have a quadratic m square a minus twice mb plus c. This value of a and value of b and the value of c you will know from your data. Because they depend on summation xi square, summation xi yi and summation yi square. Those values will be available to you. So you will know this. Now, how do you minimize this with respect to m? It's a quadratic, so give me the method for minimizing a quadratic. Yes? Suppose I don't know derivative, I want to use small algebra. Without using derivative. Of course, if you know calculus, you can minimize that. I understand that. Yes? Yes, yes.
We make a square, then...
Right, you complete the square, right?
Yeah.
You complete the square, and after you complete the square, then there is a constant term that does not depend on m. And so you set that square term equal to 0.
Yeah.
And
Yes.
if you do that, you will get exactly this. Okay?
Okay, sir.
You will get exactly this. So you understand? So it's a very simple problem. So now you have a very nice method that if you have a set of points which lie approximately on a straight line but not exactly on a straight line, and you want to find the slope of that straight line, you can do it by Legender's method of least squares. Now Legender called it the method of least square for obvious reason, because you are minimizing the sum of squares. So that is why he called it the method of least squares. Now this method of least squares now has become a very popular method whenever you try to fit a straight line to the data. So the points are, sit down, the points are all scattered around a line, not exactly on a line. But I want to find a straight line that will fit it best. This method of least square is sort of the basic tool or the basic method that people use for that. So you have learned something that you'll probably use later on as you study more and more science, that this is a very fundamental technique that is used in any scientific discipline where they have to do quantitative analysis. Because your experimental data, they're supposed to satisfy a law or an equation. But your experimental data will never perfectly satisfy that law or equation. So as you draw the curve, your collected measurements or points will lie around that curve, but not exactly on that curve. And you want to find that curve. And it is the method of least squares that helps you to do that. So you minimize those squared deviations, some of them, and you get that. Okay? You understand it? Okay. Now how much more time do I have? Is it all over, or I have 5-10 minutes more? So can I take 5-10 minutes more? Is it okay? Okay, fine. Now, do you have any question about this, first of all? Then, if not, then I will move to the next thing. Yes, if anybody wants to speak in Bengali, it's fine. You don't have to speak in English, okay? কারো কোনো প্রশ্ন আছে?
Sir, I have a question that how comets repetitively, I think we can see from it Earth repetitively.
Say it again, I couldn't hear you.
Sir, actually বলছি বাংলায় বলতে পারি?
হ্যাঁ হ্যাঁ বলো না, তোমাকে তো বললাম বাংলায় বলো।
স্যার বলছি ধূমকেতুগুলো পড়েছিলাম যে ইলিপ্টিক্যাল পাথে ফিরে আসে
We will have such questions later. I am asking whether you have any question related to what I just discussed. Anybody has any question related to? Yeah, I understand your question, but we will take it later after the lecture, okay? Okay. So, do you have any question related to what I just discussed? কারো কোনো প্রশ্ন আছে যেটা আমি বললাম, কারো কোনো জায়গায় বুঝতে অসুবিধা হয়েছে? কারো কোনো জায়গায় বুঝতে অসুবিধা হয়েছে?
আপনি যে ওই বস্কোভিকের ওই যে মানে যে লিস্টগুলো দেখালেন ওখানে যে ল্যাটিটিউডে যে মানে থিটার যে মানে মানগুলো ওইগুলো উনি কিভাবে পেয়েছিলেন?
এগুলো উনি পাননি, উনি এগুলো অলরেডি এগুলো ছিল ওনার অনেক আগে। কারণ ল্যাটিটিউড মেজার করার অনেক মেথড আছে সেটা। সো there are many ways of measuring the latitude and those were done way before Boscovich was doing this. Okay, so it was available to him. There are various methods for measuring the latitude. You can find them in the net. Okay.
আর ওখানে y square is equal to m
y equal to m sin square theta plus c.
ওখানে c টা কি কনস্ট্যান্ট মানে ওর কনস্ট্যান্ট ভ্যালু আছে কোনো?
কোনটার কনস্ট্যান্ট ভ্যালু আছে মানে?
c m sin square theta plus c.
So if they are approximately on a straight line, when you plot y against sin square theta, then that c is the intercept of that straight line. আর কারো কোনো প্রশ্ন আছে যেটা আমি বললাম তাই নিয়ে? ইয়েস, কারো কোনো প্রশ্ন নেই? সবাই সব কিছু বুঝে ফেলেছে তাই তো? আচ্ছা ঠিক আছে। ওকে, সো নাও দেয়ার ইজ এ টেস্ট ফর ইউ, হিয়ার ইজ এ কুইজ ফর ইউ নাও। So this is the picture of Legendra. And another person who worked a lot on this problem is Gauss. And actually, I'll show you another table. You see that both Gauss and Legendra was working on data where they had arc length measurements on France. This is the map of France. And so you see that they also had data at 5 points, but those are mostly near France, except 1 point. So 1 point was in Spain. And if I show you the table that they worked on, you see there the length is measured in module. Module was the unit of length in those days in Germany. But they were doing all this exercise to standardize things to bring in the metric system. Okay, so here is the exercise for you. Okay, let me see. So you see, what did you say when I asked you this question first? That how would you do it? You said that you will calculate the slope for different possible lines and take the average, right? That is this, right? The slope is y by x because the line passes through the origin. So that is this. That's what you said. But what is it that you are getting out of method of least square? You are getting this. So it's not same. Okay, and what is it? So it's this, right? Because if I take yi by xi, which is same as this, the slope, and multiply that by xi square, then I will get yi times xi. And in the denominator, you have summation xi square, which is the expression that you have here. So you see, unlike what you thought, what you are getting out of the method of least square is not a straight average, but some kind of a weighted average. So where the weight is square of the xi. Now, what is xi? Xi is the length of the pendulum. Now, in this averaging, you are putting more weight on longer pendulums, right? Because xi will be larger. Is that clear? And the shorter pendulums will get less weight. Does it make sense? If I have a short pendulum and if you have a long pendulum, which one will you think will approximate simple harmonic motion better? Longer one. So there the law will be more accurate. So it's better to put more weight on longer pendulums. So that is what is happening here. So that's what least square automatically does for you. it makes an adjustment for error in your approximation. Okay? But that's not the quiz. The quiz is here. So here is the data. It's on height and weight of people. Okay? And so you see, so it's actually the height and weight of 20 students in my class. I don't have the numbers again. So 20 people, their height and weight. Now if you look at it, if I try to fit a straight line, that will be like this. Now, you don't have to restrict yourself to a straight line, right? So if you want to find out a good equation, you may try to fit a quadratic, you may try to fit a cubic. There are many choices. Okay? So if I try to fit a quadratic, but you can fit quadratic also by the method of least square. Again, the same principle. You look at the deviations from the quadratic, which is a parabola, and then you try to minimize that. But it will be a more complex minimization problem. So between this one and this one, which one you think is better? So this is the straight line that fits by the method of least square, and this is the quadratic. Which one you think is better? Why do you think so? হ্যাঁ বলো বলো বলো। কেউ লাইনের কার্ভের উপরে কেউ নেই, সবাই এদিক ওদিকে ছড়িয়ে রয়েছে। বাট হোয়াই ডু ইউ থিঙ্ক দিস ইজ বেটার কম্পেয়ার টু দিস ওয়ান? ডু ইউ থিঙ্ক দ্যাট দ্য ডেভিয়েশনস উইল বি স্মলার উইথ দ্য কোয়াড্রেটিক?
স্যার এখানে তো ডেভিয়েশনগুলো একটু বেশি স্যার, কিন্তু সেখানে ওগুলো কম কম লাগছে।
কম কম লাগছে চোখে, তাই তো?
হ্যাঁ স্যার।
তাই কোয়াড্রেটিকের পরে আমি কিউবিক এসবে গেলে কি আরো কমবে?
সেটা আমি বলতে পারবো।
সেটা তুমি বলতে পারছো না। হ্যাঁ, কিন্তু কেউ কি বলতে পারবে যে আমি যদি এই ডিগ্রিটা বাড়াই পলিনোমিয়াল, ইফ আই ইনক্রিজ দ্য ডিগ্রি অফ দ্য পলিনোমিয়াল from line to quadratic to cubic, what will happen? Do you think that is it possible to find a polynomial that will fit the data perfectly?
না স্যার, সেরকম বলা
এরকম হবে না?
আমি বলতে পারবো না।
তুমি বলতে পারছো না? যদি আমি পলিনোমিয়ালটা ডিগ্রি খুব হাই নিই তাহলে হবে না? হবে না? ইয়েস।
ডিগ্রি বাড়াতে থাকলে ডেভিয়েশনটা কমতে থাকবে তখন।
বাট আমার প্রশ্নটা একটু আলাদা এখন। আমার প্রশ্নটা হচ্ছে আমি কি এমন একটা পলিনোমিয়াল পেতে পারি তার ডিগ্রি অনেক হাই হতে পারে, যেটা একদম পারফেক্টলি ফিট করবে ওই পয়েন্টগুলোকে?
হতে পারে।
হতে পারে, নাও হতে পারে। আমি যদি তোমাকে 20টা পয়েন্ট দিয়ে দিই, তুমি কি কখনো এমন একটা পলিনোমিয়াল খুঁজে বার করতে পারবে যেটা একদম সব পয়েন্টগুলো দিয়ে যাবে, একদম পারফেক্টলি ফিট করবে? এরকম হতে পারে? হতে পারে না? তোমাকে যদি 2টো পয়েন্ট দিই, একটা স্ট্রেট লাইন দিয়ে পারফেক্টলি ফিট করা যায়। 3টে পয়েন্ট দিই তাহলে কোয়াড্রেটিক দিয়ে পারফেক্টলি ফিট করা যায়। তাহলে 20টা পয়েন্ট দিলে
20 হলে ফিট হতে পারে, মানে ওটাকে পাওয়ারটা 20।
পাওয়ারটা কত নিতে হবে? 20 হলে পরে
দুটো নিলে একটা 19।
হ্যাঁ, 19। সো এটা যদি if I take a polynomial of degree 19, I can always find such a polynomial that will fit it perfectly. তাহলে সেটা নেবো না কেন? সেটা নাকি নেওয়া ভালো কথা? সেটা নিলে কীরকম হবে তোমাকে ছবিটা দেখাই। হ্যাঁ, যে একটা 19 ডিগ্রি পলিনোমিয়াল যেটা এটাকে পারফেক্টলি ফিট করছে, সেটা নিলে এইরকম একটা কার্ভ পাওয়া যাবে। এটা কি খুব ভালো ফিট হচ্ছে? এটাকে নেবে তুমি না নেবে না? নেবে? হাইট অ্যান্ড ওয়েটের রিলেশনশিপ এরকম হতে পারে? হাইট অ্যান্ড ওয়েটের রিলেশনশিপে মোস্ট ন্যাচারাল রিকোয়ারমেন্টটা কি? যে হাইটটা বাড়লে ওয়েটটাও বাড়বে, তাই তো? সেটা কি এখানে হচ্ছে
না?
সুতরাং এটা ভালো চয়েস নয়। সো কিপ দ্যাট ইন মাইন্ড, যে তোমার এই ডেভিয়েশনগুলো কমে গেল মানেই যে ফিটটা ভালো হলো এটা নয়, কিন্তু সবসময় এর বাইরে আরো কিছু আছে, সেটা নিয়ে তোমরা ভাববে, তাই না? তার কারণ আমি তো একদম ডেভিয়েশনটা 0 করে দিতে পারি। I can make the deviation completely 0 like that, but then I will end up getting a curve like this, which is wiggly, goes ups and downs. And height weight relationship, if you want to come up with a scientific relationship between height and weight for a group of people, you wouldn't like such an equation, for obvious reason that they should be increasing. For the quadratic that you had, it was more or less increasing. For the line, of course, it was increasing, so there was no problem with that. But as soon as I get something like a perfect fit, so I call this the problem of overfit. It's fitting too well. Okay? ঠিক আছে? So I'll conclude here. You think about this problem and how will you resolve it? So now the question is that if I have a straight line, if I have a quadratic, if I have a cubic, which one do I use? In the case of pendulum, there is a law of physics that guides me. So I have that. But when I have the data on heights and weights of people, there is no physical law to guide me. And the equation may not be same for all populations. If I look at the Chinese people and the Indian people and the British people, probably the relationship is of different nature because of their development of the body. So there, from the data itself, you have to decide what is a good choice of the equation, and these issues will come up there. Okay. Okay. So now if you want to ask any other question, you are free to ask, and if I am able to answer, then I will answer. If I don't know the answer, then I will say I don't know the answer. Now, anything related to the things that I have discussed, you can ask that first, and then maybe some other topic.
স্যার আমি বলছি যে যদি আমরা ওই হাইট অ্যান্ড ওয়েটের যে গ্রাফটা নিচ্ছি ওটা যদি মানে আমরা প্র্যাকটিক্যালি মানে একদম সার্ভে করে দেখি তাহলে ওটা যদি ওরকম মানে পয়েন্টগুলো যদি ওরকমই আসে তখন আমরা কোনটা নেব মানে
না এটা কেন আসছে বিকজ there are individual variations there, right? But suppose, what is the purpose of this exercise? Suppose you want to form a relationship between height and weight to use it in future to decide whether a person is overweight or underweight compared to the height.
Yes, yes.
Then you want a relationship that is sort of an overall fit to the entire population. And there, such a thing you should not allow. Okay? Of course, there will be individuals who are underweight, so they will fall below that curve. So in some sense, probably what is happening here, these people are underweight, whereas these people are overweight. But a normal height-weight relationship should be monotonic.
Yes, yes.
So the objective is to find that normal relationship.
Okay, sir.
Okay.
Sir, my question was that while formulating a type of equation in which we are not governed by any laws like this one, so what should we have to mainly keep in mind? As we can see that it has zero deviation, but it is of no use, this equation right here. So what is the most important for making a nearly accurate equation?
So that was the exercise, but what comes in your mind? What will you do?
Sir, I think
that is the exercise that I left.
Okay.
Okay, but tell me, what is your
Sir,
idea?
I think we should
So
take
you'd like to have a curve that sort of not only work for this data, but for future data also,
Yes,
right?
sir. Yes, sir. Yes,
and
sir.
this might be very good for this data, but as soon as I put a new point, this will
it
be
will fail,
deviating.
completely fail, yes.
So you should look at something like a prediction error. And you can do prediction error measurement in like this. So it's like this. Suppose I want to compare the quadratic and the straight line. And then I have this data and then I put a new data point there.
Okay.
And I try to look at the deviation for the new data point. And then which one gives me a better prediction, I take that one. That's one approach. There are many things, okay? So that's the exercise I wanted you to think about, and this does not have a unique answer.
Okay, sir, thank you.
Yes, any other question from anybody? Okay, so somebody wanted to ask me something about Dhumketu. What is that question? So what was your question? Now let's hear that.
স্যার জিজ্ঞেস করছিলাম যে ধূমকেতুগুলো ইলিপ্টিক্যাল পথে কি করে বারবার ফিরে আসে?
না, এটা যদি ইলিপ্টিক্যাল পথে ঘুরে তো বারবার ফিরে আসতেই হবে, কোনো তো উপায় নেই, তাই না? মানে ওদের তুমি কেপলারস ল অফ মোশন কি শিখেছো?
হ্যাঁ স্যার।
হ্যাঁ, কেপলারস ল অফ মোশন ওটা তো ইলিপ্টিকই হবে তো, না?
স্যার কেপলারস ল অফ মোশন শেখায়।
ও শেখনি তুমি, আচ্ছা। মানে এই প্ল্যানেটারি মোশনগুলো এই কেপলারস ল থেকে ওটা ওদের পাথটা ইলিপ্টিক, আর্থের পাথ অ্যারাউন্ড দ্য সান ইজ ইলিপ্টিক ফ্রম দি কেপলারস ল, বাট अगेन দ্যাট ইজ অ্যান অ্যাপ্রক্সিমেশন।
মানে স্যার ধরুন হ্যালির ধূমকেতু যেটা হয় ওটা আমাদের বারবার ফিরে আসছে, স্যার ওটা কি কোনোদিনই সে আর্থের সঙ্গে কলিশন হবে না?
হতে পারে, সেটা আমরা জানি না, কিন্তু ওর যে পাথটা ট্রেস করা হয়েছে বেসড অন সার্টেন ফিজিক্যাল লজ অ্যান্ড অ্যাজাম্পশনস, তাতে এরকম হওয়ার কথা নয়। হ্যাঁ, ও একটা পয়েন্টে তো এরকম হতেই পারে না, ধরো এই যে এটা এই একটা পয়েন্টে এটা নেগেটিভ এসছে, তাই তো, এটা নেগেটিভ এসছে, সেটা কেন হচ্ছে তুমি এই ছবিটা দেখো, এরকম যদি একটা শেপ হয় তাহলে এইখানে গুলো সব পজিটিভ হবে আর এইখানে এগুলো তো নেগেটিভ হয়ে যাবে না? আর কোনো প্রশ্ন আছে কারো? বেশি, সো ওই ডেটাতে 10টা পেয়ারের মধ্যে 9টাতেই পজিটিভ পাওয়া গেছিল, এবং আর্থের শেপটাও তো এখন আমরা জানি এরকম ফ্রম দি স্যাটেলাইট ইমেজ। ইয়েস
স্যার, আমরা এরকম মানে মেথডে আর্থের শেপ বের করছি, কারণ আমরা যদি স্পেস টাইম থিওরি ইউজ করে আর্থের শেপ বের করতে পারি।
সেসব তো তখন ছিল না, না 17th সেঞ্চুরি, আমরা 17th সেঞ্চুরি সায়েন্স করছি এখন,
হ্যাঁ,
আমরা পিছিয়ে গেছি। এখন অনেক কিছু করতে পারো তুমি, এখন তো স্যাটেলাইট ইমেজ নিলে এরকম দেখতে পাবো, কিন্তু নিউটনের তো সেটা ছিল না। আমরা সেই প্রবলেমটা বোঝার চেষ্টা করছি, নিউটন যেভাবে করছিল, এবং এইটা করতে গিয়ে যে মেথডগুলো এলো সেটাই আমরা আলোচনা করছি, মেথড অফ লিস্ট স্কোয়ার। যে মেথড অফ লিস্ট স্কোয়ারটা যেটা হলো সেটা এখন তুমি আর এইখানে অ্যাপ্লাই করছো না, শুধু তুমি বিভিন্ন জায়গায় অ্যাপ্লাই করছো, হাইট ওয়েট ডেটাতে অ্যাপ্লাই করছো, পেন্ডুলামের প্রবলেমে অ্যাপ্লাই করছো, সো দ্যাট গিভস এ জেনারেল টুল নাও।
স্যার কিন্তু এখন তো তখন তো গ্র্যাভিটেশন তো আবিষ্কার হয়ে গেছিল,
হ্যাঁ,
তো তখন গ্র্যাভিটেশন ইউজ করে তো আর্থের শেপ বের করা যায়।
এটা তো উল্টো প্রবলেম, যে গ্র্যাভিটেশনটা নিউটন মনে করছে এটা গ্র্যাভিটেশনটা ওই কারণে হয়েছে, কিন্তু অন্য কোনো কারণ আছে কি না সেটা তারা ভেরিফাই করার চেষ্টা করছে, সেই জন্যই শেপটাকে গ্র্যাভিটেশনটাকে সরিয়ে রেখে বার করার চেষ্টা হচ্ছে, যে আমরা শেপটা সত্যি নিউটন যেটা ভাবছে সেটা কিনা দেখার চেষ্টা করছি উইদাউট ব্রিং ইন গ্র্যাভিটেশন, বিকজ অফকোর্স অ্যাক্সেলারেশন ডিউ টু গ্র্যাভিটিটা ডিফার করলে ওই কারণেই করবে, কিন্তু অন্য মানে সত্যি শেপটা ওই রকম কিনা সেটা কমপ্লিটলি ইন্ডিপেন্ডেন্টলি ভেরিফাই করার চেষ্টা করছি। ওকে ওকে,
Thank you, sir, for your very mesmerizing and elaborative presentation. Now we will move to our third session for the day.
Now we have among us Professor Devidas Ghosh, Dean of Faculty Council of Postgraduate Science, Studies in Science, Vidyasagar University. Professor Ghosh is here to give some motivational talk to students to encourage and inspire the young minds. We would like to welcome Professor Devidas Ghosh on stage. So I'll be requesting our research scholar to felicitate him.
A round of applause, everybody.
Thank you, sir. Professor Devidas Ghosh is Dean of Faculty Council of Postgraduate Studies in Science, Vidyasagar University, and Professor of Department of Biomedical Laboratory Science and Management and Clinical Nutrition and Dietetics under Vidyasagar University. His research area is related to endocrinology, molecular medicine, reproductive physiology, clinical nutrition, nutrition genomics, diabetic endocrinology, molecular drug development against diabetic mellitus, herbal male contraceptive development, nutrigenomics, etc. He has more than 100 publications in different national and international reputed journals. He has received more than 4 crore for conduction research work funded by DST, ICMR, NTRF, UGC and others. He has 2 patents for identifying plant-based components. He has received different awards including Indo-Tanisian Bilateral Fellow by DST, Government of India, Shiksha in 2009, UGC, Young for conducting their PhD work. He has been BOS member in different colleges and universities since 25 years. Now sir, over to you please.
So, good afternoon all of you. My research topic actually the nutrigenomics. So, first of all I like to say something about nutrigenomics because it is a very advanced field of the nutrition or molecular nutrition. And I also speak about mainly that is the motivation, which is the pillar of the success. General actually concept of the motivation. So, first of all that is my field nutrigenomics, which is referred as the molecular nutrition. And the nutrients you also intake through the different food items that also control the gene. It is a very new idea. That idea is not actually coming till now in your, that is a higher secondary education syllabus. That the nutrient can control the gene. And another one, that is the nutri-epigenetics. That means your characters, your physical characters, your actually physique, your choice of the different foods are also controlled by your genome. You know that somebody also like eggs, somebody like fish, somebody like meat. Do you know what is the basic difference? Though they are the same family, they are brother and sisters of same parent. In spite of that, some individuals also like fish, some individual meat, and some eggs, and some veg. What is the basic difference? Have you any question about that? And that is the genomic factor which also control your food composition. You know that genome of the actually brother and sisters or brothers are not same. There is also a variation. And that variation also control your the food choice. And similarly, your physical structure is also controlled by the nutrient that can able to modulate the genetical structure, which is known as the nutri-epigenetics. The very new term nutri-epigenetics, the physical characters of the individuals is also controlled by the nutrient intake. If any racial, that means suppose the one pair of the Bengali go to the USA, and for 3 or 4 generations they also spend there, and they marry the Bengali also. In spite that, after 4 or 5 generations, the offspring, that is actually just like the physical features of that states, not the West Bengal. So this study also indicates that the environment, including the food, is the most important factor which control the phenotypic characters, not only the genotypic character itself, but also the phenotypic characters. Similarly, our research is also deals about that in some community, some of the diseases are not very high. And that is due to their food pattern. The community which also intake the marine fishes, where the omega-3 fatty acid is very high, and you know that omega-3 fatty acid is cardioprotective. So on the basis of the food choice, we can able to raise so many communicable as well as the non-communicable diseases. And on the basis of that, we also know that food is your medicine. That is a very ancient term, food is your medicine. And on that basis, the advanced research in the field of the nutrition is also going on. That how, by the modulation of the meal pattern, by the alteration of the composition of the meal, how we can able to prevent the different diseases, how we can able to promote the health status, and how we can able to control the early recovery from the diseases. So these are the new field of the research in the biological science, especially in the nutritional science. But today I also give a separate lecture, not only on my research, but I give some clues about the general motivation. Because you are also the young researcher, in the future you also contribute a great knowledge to our society, to our nation, and our future nation is also depend on your activities. From that point of view, we like to say that what is motivation and what are the different features of the motivations, what are the different guidelines to motivate you, what is the role of the society to motivate you, what is the role of your institute to motivate you, and what you will gain that if you are actually on that motivation. Actually, motivation, there is a mindset that is known as the attitude. Mindset or attitude. And that attitude is not actually coming from the actually space. It is depends on your activity. Actually, the knowledge, the information, all the information actually motivate you. The students who have actually very much eager to collect the information from so many sources, their motivation would be altered. So information is the most important driving force for positive motivation. And if you are actually motivated to achieve your goal, that actually transforms into your practice, your habit. So motivation also control your habits. Motivation also control your practice. And if the practice or habit is imprinted in your mind, then all of your work style would be changed. You would be very much eager to earn more and more knowledge, to solve more and more problems. Problem means actually we say that the research. Because main point of the research is to solve the problem, to identify the problem and to solve the problem. These are the two things of the research. So from motivational point of view, we like to say that for investigation, for research activity, to do something for the societal benefit, to increase the knowledge bank of our society, the motivation, devotion, dedication, these are the most important factors. So we like to a short discussion on that motivation. Now what is motivation? Just like that picture, that motivation is a very slow process, which is a lifelong process, continuous process, which is started from the very small object. And ultimately, we actually achieve the goal. If you think that I am motivated and tomorrow I also achieve my goal, it is not correct. So, actually motivation drive you to fulfill the action in proper way. The progress would be guided by the motivation, not perfection at first. Perfection never came at first. Progress will actually the first factor of the motivation. So motivation can able to control your progress, and if the progress is going on as per your track, you can able to achieve the perfection. So motivation, that is to perform the action properly, and we feel more in control way, systematic way, methodical way. Because to fulfill the goal, the systematic and methodical work is very much needed. It is mandatory. To be a researcher, you must be systematic, you must be methodical. And that systematic and methodical work is only under the control of motivation. If you miss the motivation, what will happen? Now, very simple thing will appear as a very hard thing. So if you are not motivated, then in your course curriculum, very simple thing will be considered as a very hard thing, and you also avoid it. But if you are motivated, you can able to do the problem, and after solvation of the problem, you would be excited, you would be energetic, and that energy will provide to solve the more and more harder problem. So motivation in that aspect is very much important aspect in the student life. Now there are so many types of motivation. One is the positive approach or positive factors for the motivation, and these are like reward, recognition, promotion in the service life. These are the positive approach of the motivation. And similarly, there are several negative approach in your motivation. What are the negative factors that actually demotivate you? Like fear, like demotion, like anger, like frustration. All such factors will demotivate. So in the course curriculum, at the time of teaching learning process, the duty of the teachers is also that to away from the partiality, to away the frustration, that if any student suffering from frustration, we must identify and to overcome that frustration to motivate. And as per UGC rule, you know that in each and every institute there is a psychological counseling. I hope that in this institute there is also psychological counseling unit to overcome the frustration, to overcome the demotivation, etc. Now reward is another dimension of the motivation, and that may be divided into two types: financial factors for the motivation, and some are the non-financial factor for motivation. Financial, you know, that is the fellowship, scholarship, and that is the financial facilities. All are the financial factor for motivation. That means if you get a scholarship, yes, you would be motivated. And you know, at present, the national government as well as the state government also open so many fellowship or the student stipend. And for that reason, if you study, that is the gross enrollment ratio. Gross enrollment ratio at the national level as well as the state level is gradually increased. And that is the motivational factors. Similarly, the parity matching, if you study in the 19th century, then the higher education as well as the secondary education level, if you study the parity matching ratio, PMR, then most of the students were boys in the secondary as well as the higher secondary as well as higher education. But from the 21st century, it has been noted that the girl students, their number is also gradually increased in the secondary as well as the higher education system. And that is the parity matching is also going on, where the financial factor of the motivation is also one of them. Non-financial factors like the environment, if the environment of your home, environment of the institute is very favorable, then you would be motivated. If the institutional environment is not so good, the motivation will not come. So, as for example, in this institute, you know that environment is very much favorable, very much actually for motivation to the student. So, environment is the most important factor. Similarly, perfect judgment of the student on the basis of their activity, it is also another motivational factors. And for that reason, UGC also give the guideline to overcome the partiality, to overcome the biasness. So this is the non-financial factors for motivation. Similarly, another one, that is the extrinsic factors and intrinsic factors of motivation. Extrinsic, that is the factors which are coming from outside, like fellowship, studentship, actually social factors. These are all the extrinsic factors. These are not the endogenous factors, these are the exogenous factors. And another one, that is the intrinsic factors, which are actually the endogenous factors, that is the factors within yourself. Within yourself. That is your competence, your attitude, your talent. These are all your concentration, your devotion, your dedication. These are all the intrinsic or endogenous factors for motivation. If you go to solve a problem, if your knowledge, that the background knowledge is also at the standard level or is also very fine, then you know that you would be motivated to do to solve the problem. But when there is some lacuna about the background knowledge, you are not motivated, you try to avoid from that problem. So these are the intrinsic factors. And we can able to modify, we can able to upgrade, we can able to alter these intrinsic factors. Extrinsic factors can be modified, okay, but intrinsic factors can be modified by your own activity. By your own activity, by your own exercise, you can able to uplift the intrinsic factors. And for that reason, you also know that some of the students which are coming from a very poor family where the environment was not suitable, but when that child comes to a favorable environment, and all such factors are also given, it has been noted that the student have been motivated properly. And that is also noted in some Ramakrishna mission also. The students are also coming to such environment that at the previous life their attitude for the teaching learning process was not so actually interested for that student. But at that environment and due to their practice, the student has been motivated for that teaching learning process. So these are also intrinsic as well as the extrinsic factors. And there is a vicious cycle between extrinsic and intrinsic factors. Extrinsic factors also control the intrinsic factors. Intrinsic factors also control the extrinsic factors. And as a result, the motivation is also noted. Now, I have already discussed about the intrinsic as well as the extrinsic factors. So I'll also skip this slide. Now, what is the academic motivation and what are the major factors in your field? That is the academic motivation. You are also under academic motivation, not professional motivation. That is the individual factors. Well-being, confidence and effort. And beliefs and values of education. You must believe that values of education. If you say that ultimate value of the education to give a job, to actually get a particular job. No, this is not the values of education. Values of education actually, that is your honesty, your accountability, your truthfulness, your devotion. And if you learn that values of education, you also establish yourself in your future at a particular place. Similarly, that is the study skills. Skill, that is the expertization, not coming suddenly. It is due to the exercise. So skillness actually coming from exercise, and that is also the individual factors. And similarly, another one, family related factors. That means parental values. What is the attitude of the parents? Because attitude of the parents also control the motivation of their child. Similarly, family support. from the viewpoint of financial support, from the viewpoint of societal support, all such family-related factors, socio-economic factors, all are involved for the academic motivation. If the family also engage the student for several other works, except the academic activities, then that student will not get the proper time for exercise. And thereby the skillness to solve the different problem, to earn the knowledge, she or he will not get the proper time. So for that reason, I like to say that family-related factors are also most important for academic motivation. Another school-related factors, I also mentioned that environmental factors of your institute. The academic environment, the physical environment of your institute is also most important for academic motivation. And similarly, social factors, that the peer relationship, friend circle, this is another factor, peer circle, that is the friend circle, neighborhood environment. At the residential place, what is the attitude of the neighborhood? So that is also another factor for academic motivation. Because a healthy competition is also going on, or it also develops when the two friends are also complementary to each other. Suppose one student is very much expert in the mathematics, and another is also very much expert in the physics. So by their peer relationship, they can able to exchange their knowledge, and by that way, the student who is weak in the physics would be motivated in that physics, taking the help of the other student. So that is the peer factors, or the friend circle is also another factor for motivation. Now you may say, what is the importance of motivation? What we get from that motivation? That's the performance. It helps the performance. Academic performance. How you can able to learn the things or the items as per your syllabi. So that is the high performance. Acceptability to change your attitude. You know that sometimes the different person also say that we are not actually learn this thing in our student life. So how we can able to develop this lecture? How we can able to deliver this lecture? No. If you have motivated, you can able to change yourself. So that is the in academic field acceptability to change. At present, you know that syllabus is always changed, and NEP from 2020, that is also changed. So how we can able to accept being a older one? We have not accommodated with that syllabus. So that is the acceptability to change by motivation. It energizes the individuals, not only teachers but also students, to motivate them to earn new things. And similarly, the role of motivation in the workplace, straightforward theoretically. Motivation, you may say that if you proceed, then we achieve the goal. This is the straightforward track. But actually, it is difficult to measure that straightforward track. When you proceed through the track to achieve the goal, there are so many actually interference. There are so many unfavorable factors. If you have a strong motivation, you also challenge that interference forces. You try to overcome that interference forces. And as a result, you can overcome that problems and achieve the goal. So that is the importance of motivation. If you are motivated, you can able to learn the knowledge, how you challenge, how you solve the so many factors, by which you can able to achieve the goal. Now, criteria to be motivated. What are the criteria to be motivated? And these are also the motivational force for research. That is the imagination, scientific imagination. If your imaginary power is high, then you can able to create something. So creativity is also come from actually scientific imagination. Another one, that the clear concept. If your concept is not clear, you would not be motivated, because you would be interfere at different steps. so many unfavorable factors will come, and thereby your progress would be affected. So clear concept, that is the knowledge, that is the information which you have collected. Knowledge bank, your knowledge bank is also most important factor for motivation. I have already mentioned devotion, dedication. These are also very much close to the motivation, very much associated to motivation. If you have no devotion, if you have no dedication, then you are unable to achieve the goal. And similarly, there is a stable mind. If your mind is very much fluctuating in nature, you are unable to achieve the goal. You would not be motivated. If you like to say that I take the such and such subject, after a few days you also change the subject, and then after a few days you also change the subject, and as a result you are unable to achieve the particular target. So that is, stable mind is another feature of motivation. Focus-centric progress. Unfocused, if your progress nature is unfocused, your motivation would be affected and you are unable to attain your target. So focus-centric progress, and that focus should not be planned for long term. That focus should be for short term. What is your focus in the month of November regarding the subject that you like to learn? What is your focused area for the month of December? What is the focused area for the month of January? And if you proceed as part-time budgeting, you can able to track the particular competitive exam, and you can able to achieve the goal. So that is the focus-centric progress. Patience is also important for motivation, because I have already mentioned that there are so many problems will come, and if you are frustrated by that problem, if you do not actually learn the patience, then motivation will not come. Truthfulness and honesty, that is the educational values also. So this is most important for motivation, and that is systematic and methodical progress. That is the period-centric progress. Period-centric progress. And you never actually claim that actually perfectness will come in the first attempt. No, no. If you actually do a particular problem, mathematical problem, and if you say that in the first attempt you also perfectly do that problem, you can able to solve the problem perfectly. No, perfectness will come later. Your progress, you also judge your progress. The progress is going on in proper way or not, and by such training, you can able to achieve that actually that is the perfectness. Now, what is the key element of motivation? You must have a goal. You must have a particular aim. Aim, that is the long period of achievement. Aim should not be achieved after 1 month or 2 months or 1 year. In your academic life, you must have an aim. And that aim, for the fulfillment of the aim, there are so many objectives. And that aim should be pinpointed. And on the basis of the aim, you also design your object. What are the objectives? And if you fulfill such objectives, you must fulfill your aim. So that is the goal. Student personal goal. One is the major goal, and that is another one, the student personal goal. Student interest and background knowledge. So that goal should be designed on the basis of the interest of the student. Suppose I do not like physical science, but if the institute or the family actually motivate me that to be an engineer, it is not possible. So the interest of the student is also another factor to be motivated. Relevant materials. That means at the time of motivation to achieve the goal, that goal is materialistic, realistic or not. So your motivation to fulfill the goal that should be a materialistic or realistic in nature. Skill of independent learning. You must learn independently. That means teacher always not help you. You must solve your problem, taking the background knowledge from the class teaching or from other source of the teaching. So independent learning skill development is the most important factor to achieve the, to fulfill the goal. And another one, the feedback response. This feedback is also between or among the student, feedback between the teacher as well as the student, feedback with so many information which are available in the actually internet. So such feedback system is mandatory to achieve the goal in connection with motivation. Now, which is the basic model of motivation? That is, motivation either drive or force the behavior or the action. And on the basis of that behavior, we can able to achieve our desired goal. And from that desired goal, we actually fulfilled our target. And on the basis of this feedback, we need our expectation. And from that expectation, if actually we fulfill our expectation, it will again drive or force for our changing behavior to achieve the other goals and so on. So it is a cyclical process. Motivation is a cyclical process, and short or small achievements in different phases are also important factor to maintain that motivational force. Now next one, ARCS model. This is the most important model for student motivation. What is ARCS model? A for attention. Attention, that is also controlled by inquiry, by participation, that is by actually concreteness. So attention, this is the first factor for student motivation. And then one, the relevance. That knowledge that you gain is also relevant to your course, relevant to your goal or not. So relevance is the second factor. A, that is the attention. R is the relevance. What is the C? That is the confidence, self-confidence for student motivation. And S, that is the satisfaction. When you actually achieve a small goal, you also satisfy oneself. So feeling of own satisfaction is the most important one for motivate oneself. And that is the own feedback. Sometimes we say that feedback, student to another student, student to guardian, student with teacher, but there is a own feedback system. By my own activity, if I achieve something, then that is the self-satisfaction. And you must feel it. If you do not enjoy that self-satisfaction, then it will not motivate for you to future work. So that self-satisfaction is the most important for student motivation. In class exam, if the student also perform a good result, then not only family will happy, but student also feel that yes, he or she can able to do something. And on the basis of that self actually satisfaction, that will drive that student to do better in the annual exam and so on. So that ARCS model is also acceptable for the self-motivation. Now, what are the 10 tips to get motivated? So motivation should be started today, not from tomorrow. If you say that, yes, I will be motivated from tomorrow, and then tomorrow you say that motivation or my attention will be started from tomorrow. No, you should start your activities from today, not tomorrow. First, that is the set your goal to get motivated. You must set up your goal on the basis of your background knowledge, on the basis of your interest, on the basis of your satisfaction. You also set your goal. And if that goal should be measurable, that goal should be achievable, that goal should be realistic. এই গোলটা এমনভাবে তৈরি হবে, মানে গোলটা এমনভাবে তোমাকে ঠিক করতে হবে যেন সেটা মেজারেবল হয়, সেটা মানে ইউ ক্যান এবল টু অ্যাসেস ইট, ইউ ক্যান এবল টু কোয়ান্টিফাই ইট, অ্যাচিভেবল, ইউ মাস্ট অ্যাচিভ ইট, ইউ মাস্ট অ্যাচিভ দ্যাট গোল, অ্যান্ড রিয়ালিস্টিক হতে হবে। আমি পলিটিক্স করি না, আমি যদি বলি আমার গোল হচ্ছে প্রধানমন্ত্রী হবো, এটা কি রিয়ালিস্টিক? আমার এটা কি হতে পারে কোনো? ঠিক সেভাবে গোলটা ওইভাবেই করতে হবে, দ্যাট ইজ দ্য রিয়ালিস্টিক, দ্যাট শুড বি অ্যাচিভেবল, ইট শুড বি রেলিভেন্ট টু ইয়োর academic activities, should align with broader life objective, and another one time bound, that is the deadline specific. If you do not follow the time budgeting, there are also two type of budgeting, financial budgeting and another the time budgeting. If your activities are not programmed with a specific time, then your goal would not be achieved. Next point, second, find your way to stay motivated. So motivation, sustainability is the most important factor. So how you sustain your motivation state? That is from sense of purpose, from books, from knowledge. From books, knowledge, you can able to stay your motivation. From podcast, that is from different video lecture as well as from internet, that is a podcast, you can able to motivate. People who align with your goals, the seniors who actually in your line, they can able to motivate and stay for motivation. And aspirants, because today's lecture are also aspirants lecture, aspiration type, inspire you, and such type of lectures, such type of actually interactive sessions also stay your motivation. Number 3, create a supportive environment. Supportive environment is very much needed for sustainability of the motivation, and that is from your surrounding environment, and from institutional as well as from domestic environment, as well as from other relationship, friend relationship and other relationship also supportive your environment. Next one, break down large goals to stay motivated. Large goals, suppose you like to say that you like to go, you would be a scientist, but that is a long term. So you also break it in so many small steps, like that picture. On the basis of the staircase, you can able to attain the particular roof. So you also break your goals in so many small sectors, and after the fulfillment of such small sector, actually the final goal you can able to achieve. So break down large goals to stay motivated. Next one, visualize the benefits of setting goals. What are the benefits? You must visualize it. What are the benefits? That the skillness, that the expertization, that is your experience. So these are all the benefits. Similarly, self-satisfaction is another benefit. These are the non-tangible benefit. Benefit are also two types, tangible and the non-tangible. Tangible মানে যেটা টাচ করে পাও, আর এটা টাচ করে পাওয়া যায় না। Self-satisfaction তুমি টাচ করে পাবে না। So non-tangible, self-satisfaction, skillness, these are all the non-tangible benefit of the motivation. And positive visualization. When you analyze a particular substance, there are two aspects, at a positive aspect and negative aspect. If you analyze the negative aspect, it will also interfere your motivation. So you actually drop that negative motivation, negative visualization. You must study the positive visualization of that particular item or particular case. 6th point, make your goal a part of your routine. I have already mentioned that when motivation would be imprinted in your mind, it become a habit, it become a practice. And when it become a practice, it will drive you like a dream. You know that APJ Abdul Kalam also said that dream, what is dream? For motivation, if you have dream, you can do something. উনি বলেছিলেন যে ড্রিম সেটাই যেটা তোমাকে বসে থাকতে দেবে না, তোমাকে ঘুমোতে দেবে না। আমরা সাধারণত ঘুমে তো ড্রিম দেখি, উনি বলছেন সেটাই ড্রিম যেটা তোমাকে ঘুমোতে দেবে না। এবং সেই অবস্থা যদি হয় তাহলে বুঝবে তোমার মোটিভেশন এসছে। এবং মোটিভেশন তখনই হবে যে if I have dream, then I can do something. And that is, I like to say that it becomes the routine work. So motivation, when transform into a routine work, when it transform into your habit, your progress would not be stopped by anyone. And you can succeed in your life, you can able to achieve your target. Number 7, take regular breaks in order to stay motivated. Break is also most important factor. If you say that I also continue my study from 7 a.m. to 11 a.m. and then I go to school. No. Continuous education or continuous any work create a lethargy, create a fatigue, and our brain is unable to imprint that information for a long period. So intermittent mental work, not only physical work, intermittent mental work is very much needed for freshness of the mind. That can able to prevent the lethargy. And if you go to the science, that is the memory formation, you know that memories are also two types, short-term memory and long-term memory. And when the short-term memory converts into the long-term memory, at that time the break is needed. Because at that time in our neural circuit, cerebral cortex and hippocampus, there is also a neural circuit for that memory formation. And at that time RNA, brain monoamines like dopamine, serotonin, these are also synthesized. And for that synthesis of these brain monoamines, RNA of the neuronal cells, for shifting of or transformation of short-term memory to the long-term memory, that rest period is very much needed. Otherwise, the memory will not form. So, in that say, take regular breaks in order to stay motivation. If you engage in that work continuously, you would be demotivated. Next one, that is 8, focus on progress, not perfection. I have already mentioned that perfection will not come at the first attempt. You study whether your progress is satisfactory or not. If the progress is up to the standard, and if you maintain that progress, then the perfection will come. So perfection, your skillness, your expertization will achieve due to the continuous progress in your particular activity. Next one, do not blame yourself when things do not go exactly. নিজেকে দোষ দেবে না, যখন পার্টিকুলার একটা কাজ করতে পারলে না, নিজেকে দোষ দেবে না। তোমায় ভাবতে হবে যে ইফ আই ক্যান এবল টু রিপিট ইট, আই ক্যান এবল টু সলভ। যদি নিজেকে দোষ দাও তাহলে কি হবে না, ইউ উড নট বি মোটিভেটেড। সো ডু নট ব্লেম ইয়োর সেলফ ওয়েন দ্য থিংস ডু নট গো এক্সাক্টলি, and move away from perfection and move towards progress. Move away from perfection. Perfection এর দিকে বেশি তাকাবে না, move towards progress. Progress এর দিকে বেশি তাকাও, তাহলে পারফেকশন চলে আসবে। And number 9, celebrate small achievements, and that is the self satisfaction. That is, acknowledge and celebrate your small wins. That will drive to keep motivation at high, challenge those negative thoughts, and the sustainability of the motivation that will maintain. And if the second step is maintained, it positively reinforce your motivation. So that is, celebrate small achievement. Your small achievement you also celebrate own self as well as your friend circle as well as in your family, and that will motivate you to do the more harder job. And 10th one, practice self-comparison. Not with other comparison. That is the actually unhealthy comparison, unhealthy competition. Self-comparison, that what was your status in the previous month and at present what is your status. By that self-comparison, you can able to study your progress rate. So self-comparison is the best way for progress. Now, effective way to motivate students, that is create a positive work environment in the classroom as well as in the institutional. That positive environment should be maintained. Teachers should be understand the students and reduce the workload. Workload should be distributed in very small sector, not a continuous workload. And then positive reinforcement. You also study the positive factors that will motivate you and ignore the different negative factors that will demotivate. Motivate individuals rather than team, because for the student motivation, individual motivation is the most factor. If the teacher thinks that I can able to motivate all the students who are present here, it is not possible. So individual motivation, that is the best way to motivate the students. And rewards, intrinsic and extrinsic motivation, that can be enhanced by such reward. So effective way to motivate the students. And that is the motivational factors that I have already mentioned, that recognition, work ethics, that is the human values in that particular work. Work ethics, that is the your accountability, your honesty, your truthfulness. And another factor I have also mentioned, scholarship, stipend, that also motivate you. Culture, friend culture, family culture, institutional culture also motivate you. And learning process, not only the learning in the particular institute as well as the learning from the different internet or from libraries. Career growth, that also motivational factors. Health status. If your health do not permit your progress, your motivation would not be sustained. So health status is also another factor for sustainability in motivation. Transparency, your goal should be transparent, your progress should be transparent. And work-life balance, you also balance your work in your daily period. That is the work-life balance. If it is imbalance between your academic activities, your family activities, then the motivation would be affected. And reasons for lack of motivation. What are the factors that actually lack the motivation, that actually interfere the motivation? First one, environment, unfavorable environment. Communication, if there is a communication gap, then there is a lack of motivation. Low self-confidence, I have already mentioned self-confidence is the most important factor for motivation. So if you have a low self-confidence, you are unable to maintain your motivation. Similarly, the unfocused progress. Personality, if your personality is very low, then the motivation will not be sustained. Fear, these are all the factors that actually interfere the motivation. Now overcome the challenges. You know that to achieve the goal there are so many challenges. And what are the ways by overcome the challenge? That is the ABCD rules. A for acquire and achieve. B for bond and belong. You also bonding with that problem and to try to study that problem and how to overcome that problem. Comprehend and challenge. And number D, that is the define and defend. So overcome challenge to achieve the goal. This is the main theme to actually solve the challenges. So this is all about the general motivation by which you can able to sustain the goal. কোনো কোশ্চেন আছে? সব খিদে লেগে গেছে মনে। কোনো কোশ্চেন আছে কি বলো? কিছু কোয়ারি আছে? কারো কোনো জিজ্ঞাসা আছে? হ্যাভ ইউ এনি কোয়ারি? ঠিক আছে নাও
Thank you, Professor Ghosh, for sharing your encouraging words and insightful thoughts with us. Our students must be benefited and motivated by it a lot. Thank you once again. Now it's time for lunch break. In post-lunch session, we will have our lab visits and mobile science exhibition parallelly. In the evening, we will be gathered here again in the seminar hall for science shows and exhibition. Thank you all.
বন্ধ ক্যারিয়ার না, এই ক্যারিয়ারে স্যার পুলিশ শুরু করে দিচ্ছে, দুটো কমেন্ট করে স্যার। দুর্দান্ত কেরিয়ার না, এই কেরিয়ারে স্যার পুলিশ হতে গেছে দুর্গম খবর চলছে।
শশা বছর হবে, কিন্তু পিছনটা আরো এক্সপোজ হয়ে যাচ্ছে। থাক, এটাই থাক। দেখো কি করবে।
রিফ্লেকশন পড়ছে
কফি করবে দেখ দোস্ত প্রথম 10 টাকা আমি তোকে বলে দিয়েছি। আরে বাচ্চাদের প্রত্যেকের তো বয়স
টাইম শেষ হয়ে গেল।
আমি দেখতেই তো পাইনি প্রথমে ভুল ভাল করে হচ্ছে তো মহা আরে বলুন না
বিরাট
কোনটাই তুলতে বেশি কষ্ট হচ্ছে, এটা তুলতে বেশি
না কি করছো রান্না
এটা কি বলতো না গাড়ি দেখি
আর এটা খুলে আছে, এটা না খুলে এটা যে উপরে উঠছে মানে এটা খুলছে আর বাতাসটা পেট্রোল বাতাস কিনে এসছে আর এবার ভাই হয়েছে যখন এটা উঠছে এটা দেখো এটা টিপটপটা লাগে করে থাকে মানে সব খাই বলতে পারে ঠিক আছে এটা কি বলছে মানে ফালতু এটা খুলে গেল এবারে বাতাস
সন্ধ্যাবেলা এখানে ঘুরে নেবে কি পাওয়া যাবে না কি গান শুরু হয়েছে
হয়ে গেছে লাস্ট। একজন শুরু করেছে। নামতে বলো না।
ওই